Operating Systems. About this module. Welcome to the Operating Systems module. In this module, you'll learn about installing, configuring, maintaining, managing, and troubleshooting techniques for common operating systems, including Windows, Mac OS, and Linux. You'll practice partitioning and formatting a disk in a simulation so a user can have a dual boot setup of Windows and Linux. You'll also learn about managing users, groups, and permissions. You'll play the role of a vigilant IT support technician checking for compliance issues in a license management audit. Finally, you'll learn how to troubleshoot typical operating system and application errors, from critical errors to application freezes. Learning objectives. After completing this module, you should be able to compare the features of popular desktop and mobile operating systems. Apply the steps to install and set up an operating system. Determine the processes to perform various regular system updates. Use a disk management tool to create and format a new partition in storage to install a second operating system. Select a system backup and storage method. Distinguish between user management tasks to manage operating system security through users, groups, permissions, and policies. Prepare permissions to manage users. Interpret results from a license audit. Select diagnostic tools and troubleshooting techniques across operating systems for issues and errors. Apply appropriate troubleshooting techniques to common operating system issues. About this lesson, installing and configuring desktop operating systems. In this lesson, you'll learn about installing desktop operating systems and configuring them to meet organizational and user requirements. Introduction to operating systems. An operating system, OS, is the fundamental software that manages the hardware and software resources of a computer or mobile device. Think of an operating system as the conductor of an orchestra. In a computer or mobile device, the operating system ensures that different parts work together harmoniously. It orchestrates parts such as the memory, processor, and applications. It manages tasks and allocates resources to them. It also manages all the hardware and software on a device. An operating system provides the user interface to interact with the device. Overall, it's the core software that allows a device to function and perform various tasks. Initially, operating systems were simple. Computer scientists used them to manage basic computing tasks in large, room-sized computers. As technology evolved, so did operating systems. For instance, by the 1980s, computer engineers developed graphical user interfaces, GUIs, that made computers more user-friendly. GUIs like those in Windows and Macintosh operating systems. 1991 saw the release of the Linux operating system. This is an open-source operating system, meaning that its code is freely available for anyone to use and modify. Each step in the evolution of operating systems has aimed to make computers more powerful yet easier to use. In desktop computers, operating systems such as Windows, Mac OS, and Linux dominate, offering unique features and interfaces. Mobile devices, however, rely on operating systems designed for touch screens, such as iOS and Android. Operating systems continue to evolve, blending with the hardware to create seamless, intuitive experiences for users. They are crucial in making modern devices accessible and efficient, serving as a bridge between the user and the complex world of computing. Common operating systems and their features. Operating systems have evolved significantly since their initial development, shaping the way users interact with technology. Early operating systems include Xerox Alto, Apple Lisa, and Microsoft Windows. Xerox Alto was a pioneer in 1973 by introducing the first GUI. This was revolutionary in making computers more user-friendly and accessible. In 1983, Apple Lisa brought the GUI concept to the consumer market, albeit at a high cost. Then, in 1985, Microsoft Windows further popularized the GUI, making it a standard for personal computing. These developments laid down the tracks for the vast and complex digital world users navigate today. Select each section to learn more about common operating systems and their features. Microsoft Windows. Since its first release in 1985, Windows has become the most widely used desktop OS in the world. Evolving through various versions, users are familiar with it in both personal and professional computing environments. Microsoft Windows OS offers the following distinct features. Microsoft Windows is compatible with a wide range of hardware and software. Windows OS can run on a wide range of hardware, from high-end PCs to budget laptops and tablets. This flexibility makes it accessible to a broad spectrum of users, from casual users to business professionals. Windows offers a higher degree of customization compared to Mac OS. Users have flexibility in modifying the system settings and system files. This flexibility is advantageous for those who like to tailor their computing environment to their specific needs. Although Windows is not an open-source OS, users can set up their Windows computers to run with an open-source OS, such as Linux, on the same hardware using a dual boot setup. Dual boot refers to the process of installing two or more operating systems on a single computer and being able to choose which one to boot into when starting the computer. This functionality is partly because of the vast array of drivers and support available for different hardware under Windows. Apple Mac OS. Originating from the Apple Lisa, Mac OS, previously OS X, is a Unix-based operating system used on Apple devices. Often preferred by creative professionals, it offers a stable and consistent user experience focusing on multimedia and design. Mac OS offers the following distinct features. Mac OS is known for its sleek, intuitive user interface, characterized by a clean and elegant design. The interface prioritizes simplicity and efficiency, making it easy for users to navigate the system and quickly find what they need. Apple places a strong emphasis on security and privacy in Mac OS. The operating system includes built-in encryption, anti-malware features, and strict app permissions. Regular updates provide additional layers of security to protect against emerging threats. One of the significant advantages of Mac OS is its seamless integration with Apple hardware, including iOS devices, Apple Watch, and iCloud. Features such as handoff, AirDrop, and continuity allow users to work across their Apple devices effortlessly, enhancing productivity and convenience. Linux. Created in 1991 by Linus Torvalds, Linux is unique as an open-source operating system. Software developers, IT professionals, and tech enthusiasts favor it for its robust security, powerful command line interface, and extensive customizability. It's also a popular choice in academic and research circles because of its flexibility and open-source nature. Linux offers the following distinct features. Linux offers extensive customizability. Users can choose from numerous distributions, such as Ubuntu, Fedora, or Debian, each with its own set of features and user interfaces. Beyond this, users can customize almost every aspect of their system, from the look and feel of the desktop to core system functions. Most Linux distributions are free to download, use, and share. This accessibility is a significant advantage for users not wanting to invest in software licensing fees. The most defining characteristic of Linux is its open-source status. This means that its source code is freely available for anyone to view, modify, and distribute. This open-source approach fosters a community-driven development model where developers around the world contribute to its various distributions. Linux generally requires fewer system resources than other operating systems, allowing it to run efficiently on a wide range of hardware, including older and less powerful machines. This efficiency makes it an attractive option for reviving older hardware or for use in resource-constrained environments. Apple iOS. Developed by Apple, iOS is a mobile operating system that powers iPhone and iPad devices. iOS offers the following distinct features. iOS has a vast app ecosystem, with millions of apps available on the Apple App Store. Apple checks that these apps meet its quality and security standards, ensuring users have access to a secure and diverse range of applications. iOS runs exclusively on Apple hardware, ensuring seamless integration and optimization for a smooth user experience. iOS devices work well with other Apple products, such as Mac computers, Apple Watch, and Apple TV. This offers users features such as handoff, iCloud, and AirDrop for a connected experience. iOS delivers high performance and battery efficiency, particularly on mobile devices that have less powerful hardware than laptops or desktops. Google Android. Android OS, developed by Google, is widely adopted across a multitude of devices from different manufacturers. Android offers the following distinct features. Through the Google Play Store, Android provides access to a vast array of apps. Unlike iOS, Android also allows the installation of apps from third-party sources, offering users more freedom in app choices. Android runs on a wide range of devices, not just phones and tablets, including wearables, TVs, car systems, and even appliances. This versatile platform for smart device integration deeply integrates with Google services and applications, such as Google Assistant, Google Maps, and Google Drive. This provides users with a cohesive ecosystem in the Google suite of products. The Android Open Platform allows users and manufacturers to customize the interface and functionality extensively. Users can alter everything from the home screen layout and widgets to the default apps and even the system's overall look with third-party launchers. When do IT technicians install or reinstall operating systems? A woman with a headset working on her laptop. Computers generally ship with a pre-installed operating system, but there are several reasons an IT support technician might need to install or reinstall one. An IT support technician might install or reinstall an operating system in the following scenarios. Reassigning a used computer to a new user. Setting up new hardware to ensure that it meets an organization's standard OS configuration. Upgrading a user's computer with the latest operating system. Reinstalling an operating system in case of a security breach to ensure the incident is fully remediated. Now you know about some of the popular operating systems available today and scenarios for when to install or reinstall them. Let's follow the steps to install one. Installing an operating system. Watch the following video about installing an operating system. Page 1 of 2. Video transcript. Installing an operating system. Meet Samuel, an IT support technician who is repurposing a computer for a new employee in his organization and needs to install a new operating system. Installing an operating system is more than just the basic installation. Samuel must follow several important steps to set up the system correctly. He will choose an operating system, backup data, create installation media, begin installation, install the OS, customize settings, and complete the installation. Samuel's first task is to choose an operating system. He considers the device's intended use, compatibility, and organizational standards. Opting for Microsoft Windows, Samuel checks the official website to ensure the device meets the minimum hardware requirements. Though the computer is for a new user, Samuel backs up all local data files to a cloud storage archive. This precaution safeguards any information that might be needed in the future. Samuel needs to install the OS from physical media, so his next step is to create installation media. For Windows, he uses the Windows Media Creation tool to create a bootable installer on a USB drive. A bootable installer is a storage device that contains all the necessary files to install an operating system on a computer. When Samuel uses this device to start up a computer, it loads the installer for the operating system instead of the computer's regular operating system. To begin the installation, Samuel inserts the USB drive and restarts the computer. He enters the BIOS/UEFI setup by pressing a key immediately after he turns on his computer. The key is specified in the documentation that came with the computer. In the BIOS/UEFI, he changes the boot order to prioritize the USB drive, saves the changes, and then restarts the device. As the computer restarts, it loads the Windows installer from the installation media. Samuel selects the language, time, and keyboard preferences, and follows the on-screen instructions to install the operating system. This includes entering a product key, formatting the hard drive, and installing the operating system files onto the computer's hard drive. After the OS is installed, Samuel sets up a user account. Post-installation, Samuel customizes settings. He adjusts settings related to privacy, configures network settings to connect to the Internet, and enables system services, aligning them with the user's needs and organizational policies. Finally, Samuel completes the installation by restarting the computer without the USB drive inserted to confirm that the operating system is correctly installed. He also installs any recent updates to ensure the OS is up to date. Page 2 of 2. Samuel has systematically followed the necessary steps and installed the new operating system. He is now ready to proceed to the next stage, personalizing the system to suit the new user's needs. You just learned about these key steps in the process to install an operating system. Choose an operating system. Backup data. Create installation media. Begin installation. Install the OS. Customize settings. Complete installation. After installing an operating system, an IT support technician needs to complete additional, important setup steps. Install drivers. Device drivers facilitate communication between the OS and hardware components like graphics cards, printers, and network adapters. Most modern operating systems attempt to install necessary drivers automatically. Sometimes, specific hardware components might not work optimally with the automatically installed drivers, or the OS might not find a suitable driver. In such cases, manually downloading and installing the latest drivers from the hardware manufacturer's website is necessary. This ensures that all components can function at their full capacity and with all available features. Install essential software. Most users will require some additional software applications, such as work-related software, such as productivity tools, office suites, design software, or other professional applications relevant to the user's role. Personal use applications, including web browsers, media players, and photo editing tools. Security software, like antivirus and anti-malware programs, especially if they are not included in the OS. The installation instructions for these are usually in the documents that came with the software or on the manufacturer's website. Restore data. If the OS installation is to reinstall an OS, replace an outdated OS, or replace a device for an existing user, it is likely that there will be data to restore to the new OS. This might include documents, photos, music, and videos. Restoring data is an ideal time to consider the organization of the data. Consider setting up a folder structure to make navigating and using the data easier. Creating recovery media. Recovery media enables technicians to repair or reinstall the OS in case of future system failure or serious errors. Most operating systems include tools to create a recovery drive, typically on a USB drive or DVD. The recovery media includes essential files for troubleshooting and restoring the OS. Activity: install and set up an operating system. Employability skills. Analytical thinking. In this activity, you'll apply what you just learned about installing and configuring an operating system by following the steps. Imagine you're the IT support technician for Pet Paws Support Centers, which offers veterinary care. You need to install and set up a computer for Jemima, the new office manager. Jemima has previous experience in office management using Microsoft products. She will need to connect to the Pet Paws network and use the printer in the reception area. 1. Choose an operating system. You begin by revisiting Jemima's needs. You note that she is familiar with Microsoft products and that she will be using an existing printer. You check the device that you will be working with and note that it's a mid-range PC. You also check the printer in the reception area and note that it is a new printer with lots of functionality. 2. Backup data. Because Jemima is a new employee, she has no existing data to back up. You don't need to complete this step. 3. Create installation media. You already have a bootable installer for Windows on a USB drive, so you're all set. 4. Begin installation. Now you're ready to start the installation, so you plug the USB drive into the computer and restart the computer. You press a key as it restarts to enter the BIOS/UEFI setup. 5. Install the OS. Now that you've changed the boot order, you restart the computer and the installation begins. As the computer restarts, it loads the Windows installer from the installation media. You select the following options. Language, English, United States. Time and currency format, English, United States. Keyboard or input method, US. 6. Customize settings. After you install Microsoft Windows as the OS, you connect to the corporate network using your administrator credentials. You configure Jemima's privacy and network settings to meet your organization's policies. 7. Complete installation. When everything is correctly configured, you remove the USB drive and restart the computer. Finally, you run Windows Update to ensure that the operating system is up to date. Post-installation device setup. Checking your notes again, you find that Jemima will be using the reception area printer. You try to connect to the printer, but a message about a missing driver displays. Post-installation device setup. After you download and install the printer driver, you find that Jemima's PC now connects to the reception area printer and it works. Since Jemima is a new employee, she doesn't have data that you need to restore. She'll be able to access the corporate network for all of the information she needs. Conclusion. You successfully followed the steps to install and configure an operating system. You started by determining the most appropriate operating system for Jemima's needs. You then created the installation media and changed the boot order in the BIOS/UEFI setup to begin the installation. You chose appropriate options during the installation process, connected to the PET/POS network, and resolved a driver issue. Finally, you identified the step to create recovery media to help repair or reinstall the operating system should the need arise. Configuring a desktop operating system. After installing the operating system, software, and drivers, it's time for the IT support technician to configure the operating system. This includes 3 key tasks. Configure system settings. System settings tend to include the configuration of the computer itself and the hardware devices connected to it. Performance optimization enables IT support technicians to adjust settings for power management, visual effects, and background processes to enhance performance. Usability enhancements enable technicians and users to tailor system notifications, display settings, and mouse or touchpad settings for a more personalized experience. Set up network connections and user accounts. It's also important at this stage to configure network connections and user accounts. Configure Wi-Fi or Ethernet connections to ensure secure and stable internet access. Create and manage user accounts, assign privileges, and set up parental controls if needed. Customize the desktop environment. Users or technicians might also choose to customize the desktop environment. They might personalize the appearance by changing the desktop background, color schemes, and fonts. They might organize shortcuts and widgets for quick access to applications and information. This might include arranging desktop icons, creating shortcuts for frequently used applications, and adding widgets or gadgets for quick access to information like weather or news. Successfully completing these tasks ensures that the operating system meets the user's performance and usability requirements, provides a safe and secure computing environment, and delivers the personalized desktop that the user needs. Configuring accessibility features. Most modern operating systems like Windows, Mac OS, and popular Linux distributions offer a range of accessibility features. These assist users with various abilities and disabilities, including those who use alternative ways to interact with their computers. IT support technicians might need to set up or assist in setting up accessibility features for the users they support. Common accessibility features. Here's a list of some of the common accessibility features available in many operating systems. Screen readers, these tools read aloud the text displayed on the screen, which can benefit users with visual impairments. They can read text from menu items, buttons, navigational instructions, and images. A screen reader can be turned on and voice settings adjusted. Text-to-speech, this feature converts typed text into spoken words, reading it aloud from top to bottom. Text-to-speech can help users who have reading difficulties and those who simply want to maximize their productivity by listening to text rather than reading it. Adjustments can be made for voice type and speaking rate. Magnification and zoom, this feature enlarges the screen or parts of it, which is useful for users with low vision. Zoom levels and focus can be customized. High contrast themes, this enables users to change the display to high contrast colors, which aids users with visual impairments. Various high contrast color schemes are available. Speech recognition, this enables users with mobility impairments to control their computer and dictate text using their voice. This feature requires initial training to recognize the user's voice. Closed captioning, this enables users who are deaf or hard of hearing to use closed captioning to display on-screen text of audio content. They can customize font size and color. Keyboard customization, features like sticky keys, filter keys, key remapping, or on-screen keyboards assist users with limited dexterity or motor skills. Mouse and touchpad adjustments, this enables users with physical impairments to customize how the mouse and touchpad work. They can alter the pointer size, speed, and button configurations. Setting up accessibility features. While the exact location of accessibility feature settings varies across operating systems, they generally all require similar types of configuration. Select each card to learn about 3 key steps technicians take to set up accessibility features. 1. Go to Accessibility Settings. In Windows, go to Settings. Select Ease of Access. On Mac OS, open System Preferences. Select Accessibility. In Linux distributions, like Ubuntu, these settings are typically found in Settings and Universal Access. 2. Explore and customize the settings. Take time to explore various features available under the Accessibility menu. Customize each feature according to specific needs. For example, adjust the speed of the screen reader, the level of magnification, or the sensitivity of the mouse. 3. Test and adjust the settings. After setting up, test the features to ensure they meet user requirements. IT support technicians, or users, might need to go back and adjust settings as users become more familiar with how the settings work in day-to-day use. What do you think? Employability skills. Resourcefulness. You learned about common accessibility features available in operating systems. Reflect on one of the features that help users with visual impairments interact with their devices, screen readers. Do you think that only people with blindness or low vision use screen readers? Or do others? Who? Enter your response in the following text box. Writing an answer is a good way to process your thoughts. These answers are for your use only. You have the option to download your response and save it. It will not be saved in the text box when you move on in the course. Evaluate your thinking. Does your answer account for the following? People with blindness and low vision make up the majority of screen reader users with disabilities. But, there are others who don't have visual impairments who might need or want to use a screen reader. People who are deaf or hard of hearing also use screen readers. People with cognitive impairments, motor disabilities, and multiple disabilities also use screen readers. People without disabilities also use screen readers. They can assist people with lower literacy and non-native language speakers. Screen readers can benefit anybody who prefers to listen to content. Source: 5 Myths about Screen Readers That Can Hurt Accessibility, opens in a new tab, Bureau of Internet Accessibility, June 2021. Career Highlight: IT Support Technician. Career Management Skills. You can find plenty of job openings for IT support technicians, and you'll find them across industries, from technology to healthcare. The regular tasks a technician performs will be similar across those industries. An IT support technician might begin their day by monitoring and prioritizing issues reported to the IT help desk, ensuring a timely and effective response to troubleshoot user problems. They configure and maintain workstations, manage user accounts, and handle installations and updates of hardware, operating systems, and software. They troubleshoot a range of hardware and software issues. They are also responsible for keeping an accurate inventory of equipment and software licenses. Additionally, they play a key role in onboarding new users, contributing to network management, and developing training materials. A significant part of their job is to build positive relationships with end users, providing a supportive and welcoming environment. Activity: analyze and evaluate job postings. Employability skills. Growth mindset. Explore open positions for IT support technicians. Access Indeed.com, opens in a new tab. Search for IT support technician jobs. Consider using other search terms such as IT support specialist and IT help desk technician. List 2 to 3 jobs that interest you and the skills required for each. Summary and looking ahead. In this lesson, you learned how to install, set up, and configure an operating system. These are essential skills for an IT support technician to provide users with the tools they need to do their jobs. The next lesson covers the regular tasks technicians need to perform to keep newly installed operating systems functioning well. About this lesson, performing system maintenance tasks. In this lesson, you'll discover the importance of scheduling and automating regular system maintenance to keep computer systems optimized and running as they should. You will learn about the processes IT support technicians perform for regular system updates. You'll explore disk management tools they use and have the opportunity to simulate using one. You'll also learn about disk cleanup and backing up systems. Operating system maintenance. Picture a sleek, high-powered sports car, a spectacle of engineering and speed. However, if it never receives routine maintenance, like oil changes or tire rotations, its performance unavoidably starts to deteriorate. Gradually, what was once a smooth and exhilarating ride becomes filled with issues. Neglecting essential upkeep diminishes the car's efficiency and critical components begin to deteriorate. A masterpiece of speed and design turns into a failing machine. Just as a car requires regular services like oil changes, tire rotations, and engine checks to run smoothly and efficiently, an operating system needs consistent maintenance, such as updates, backups, and security checks, to ensure optimal performance and security. IT support technicians should schedule regular system maintenance tasks, which include the following: operating system and software updates. Configure the OS to check for and install updates automatically, during off-peak hours. This ensures users receive important updates promptly without disrupting their workflow. Security updates. Security updates are patches released by OS developers to fix vulnerabilities that malware or hackers can exploit. It's important to regularly install these updates to protect devices from new threats. Antivirus software updates. Antivirus software must be updated regularly to protect against the latest threats. These updates provide new virus definitions and enhance software to detect and remove malware. Hardware driver updates. Updating hardware drivers ensures compatibility with the OS and improves the overall performance and stability of connected devices. Disk cleanup. Disk cleanup includes deleting unnecessary files, defragmenting disks, and reorganizing data. These tasks help to maintain optimal disk performance and prevent the system from running slowly. Performance optimization. Regularly clearing temporary files, uninstalling unused programs, managing startup applications, and running system performance checks help to keep the OS running smoothly. System backups. Regular system backups provide resilience in case of hardware or security failure. Run them weekly and whenever any significant changes are made to a device. Backups can be stored on an external hard drive or cloud storage. It's important that backups include significant files and system settings. Operating system upgrades. Regularly check for major OS upgrades to give users access to improved features, enhanced security, and better performance. Always review system requirements before upgrading to avoid any compatibility issues. Automated maintenance. Picture a high-powered sports car with an advanced onboard diagnostic system that alerts the driver when it needs a service, schedules service appointments automatically, performs minor tune-ups on its own. This system ensures that the car is always in top condition, preemptively addresses potential issues, and saves time for the owner. In a similar way, automated maintenance streamlines processes and enhances system reliability for IT support technicians. Automated maintenance is the process of setting up software tools and systems to perform maintenance tasks automatically without the need for manual intervention. This can include automatic updates to the OS and software applications, scheduled disk cleanups, and automated system monitoring for potential issues. Automated maintenance runs in the background, often during times when the computer is not in heavy use, to minimize disruption to the user. Automated system maintenance has many benefits for IT support technicians. Efficiency. Automating routine maintenance tasks saves significant time and resources, allowing IT support technicians to focus on more complex and demanding issues that require human intervention. Consistency and reliability. Automated processes ensure that maintenance tasks run consistently across all systems, reducing the risk of human error and ensuring that critical maintenance tasks are not overlooked. Enhanced security. Regularly and automatically updating security features and software patches is essential to protect against new vulnerabilities and threats. Automation applies these updates as soon as they become available. Proactive system management. Automated tools often include monitoring capabilities that can alert technicians to potential issues before they become serious problems. This ensures proactive management of the IT infrastructure. Compliance. In many industries, keeping software and systems up to date is not just a best practice but a regulatory requirement. Automated maintenance helps in adhering to these compliance standards more easily. System update methods. System updates are the process of installing new or revised software components to an existing operating system, OS, to improve its functionality, security, and performance. These updates address vulnerabilities, fix bugs, and enhance the overall user experience. Software manufacturers typically release updates that range from minor changes to significant upgrades. There are 4 key types of updates that IT support technicians should regularly perform or configure to run automatically. Regular OS updates. Security updates. Antivirus software updates. Hardware driver updates. Let's learn about the process for each of these. Regular OS updates. Managing regular system updates is an essential task for IT support technicians to ensure the health and security of operating systems. 1, 2, 3, 4. 1 of 5. Introduction. A man working on a laptop. The process begins with accessing the update settings in the OS. These are located in the system settings of the operating system. For example, in Windows, go to Settings and select Update and Security. In Mac OS, go to System Preferences and select Software Update. IT support technicians can use these system settings to manage how an operating system receives and installs updates. Step 1. Configure automatic updates. Most operating systems offer the flexibility to choose how the system handles updates. IT support technicians generally have 2 options. Download and install updates automatically. Download updates automatically, but require manual approval for installation. The second setting allows technicians to review updates before the system applies them. For critical systems or environments where stability is vital, it might be preferable to review updates before installation to ensure they don't disrupt important operations. Step 2. Schedule updates. Technicians can choose times for updates that minimize disruption, often during off-peak hours, such as overnight or at weekends. This is particularly important for systems that require a restart following an update. They can also configure the frequency of these updates based on the criticality of the system, daily, weekly, or another suitable interval. Step 3. Monitor update logs. IT support technicians should regularly monitor update logs to check that updates were installed successfully and identify any errors or failures in the process. The specific location of these logs varies by operating system. For example, in Windows, the View Update History option provides this information. Step 4. Manually check for updates. Despite configuring automatic updates, technicians should periodically perform manual checks for updates. This helps to ensure they don't overlook or wait to perform critical updates, especially if there have been known issues with the automatic update process. By conducting these checks, IT support technicians can guarantee that the system is up to date with the latest security patches and feature improvements, thus maintaining optimal system performance and security. Security updates. Security updates are key to addressing vulnerabilities that malware or hackers can exploit. Introduction. A woman wearing glasses working on a laptop. IT support technicians should prioritize the immediate installation of security updates as soon as they become available. The prompt application of these updates is essential to protecting systems against emerging threats and reducing security breaches. Step 1. Use centralized security management tools. In environments where an IT support technician is responsible for managing multiple machines, it's recommended that they use centralized security management software. This software facilitates the distribution and tracking of security updates across all devices in the network, streamlining the update process and ensuring that no machine remains vulnerable. It also allows technicians to monitor the update implementation efficiently across different systems. Step 2. Verify updates. After an IT support technician applies a security update, they should verify the success of the update. Technicians typically verify the update by checking the system's about or system information settings to confirm that the system reflects the new version of the software. This step helps ensure that the update has been installed successfully and is functioning as intended. Step 3. Test for compatibility. IT support technicians should then run basic system checks to ensure that the update has not introduced any new issues with system functionality. This might include checking software applications, hardware compatibility, and overall system performance. These checks help to identify any potential conflicts or problems that the update might cause, allowing for prompt resolution and maintaining the system's stability and reliability. Antivirus software updates. Updating antivirus software is a critical process for IT support technicians that ensures the software can identify the latest circulating viruses. Introduction. A man holding a tablet and working on a laptop. Antivirus software uses definitions of viruses to identify and remove them. When a new virus appears, the antivirus software manufacturer adds a definition to their list, which then needs updating in every user's system. Step 1. Check for updates. An IT support technician typically begins this process by opening the antivirus program installed on the system to access the settings and options needed to manage updates. Once the antivirus software is open, the technician finds check for updates or a similar feature within the program's settings or dashboard. Step 2. Configure for automatic updates. Alternatively, an IT support technician can configure antivirus software to update automatically. This configuration ensures that the software regularly updates itself with the latest virus definitions and security features, providing continuous protection against new threats. Typically, the technician will find the options to configure automatic updates within the settings of the antivirus software. If necessary, they can investigate the specific software's help documentation to guide them in the task. Step 3. Restart the system. Some antivirus updates might need a system restart to finish the installation. In such cases, IT support technicians carry out a restart when prompted. This step is important for the proper installation and activation of the updates, ensuring that the antivirus software operates effectively and provides the necessary protection. Hardware driver updates. In the process of maintaining and optimizing computer systems, an IT support technician often deals with the task of updating hardware drivers. Introduction. Hardware drivers control the hardware in a device. By updating drivers, IT support technicians can prevent hardware and software conflicts and avoid the errors that they cause. Step 1. Identify outdated drivers. This process starts with identifying outdated drivers. IT support technicians can use the operating system's device manager to scan and identify any hardware components that might require driver updates. This tool provides a comprehensive view of the hardware installed on the system and the status of their respective drivers, allowing the technician to pinpoint which ones need attention. Step 2. Download device drivers. Once an IT support technician has identified the need for an update, they must download the appropriate driver from the hardware manufacturer's website. Technicians navigate to the Support or Downloads section of these websites and download the driver. They need to be careful to select the driver version that corresponds precisely to the specific hardware model and the operating system version in use. Step 3. Run the driver installer. After downloading the appropriate driver, the technician runs the downloaded installer and follows the on-screen instructions to install the new driver. This process typically involves a series of prompts that guide the technician through the installation, ensuring that they correctly integrate the driver into the system. Step 4. Restart and test the computer. Finally, after the driver installation is complete, the technician must restart the computer. This activates the new driver and ensures it functions as intended. After the restart, the IT support technician can test the performance of the device associated with the updated driver to confirm that the update has been successful and that the hardware is operating correctly. By following these system update methods, IT support technicians can effectively manage regular updates. This helps them protect their systems with the latest security and antivirus patches and benefit from the latest software and hardware features and improvements. This proactive approach to system maintenance is important in reducing vulnerabilities and enhancing overall system performance. Disk management. Disk management is another important task in the maintenance of a computer's storage system, directly impacting its performance and efficiency. Disk management refers to the overall management of disk drives and partitions. Partitions, sometimes called volumes, are segments of a computer's hard drive that the operating systems treat as separate and distinct units. Partitioning a hard drive effectively divides it into multiple independent sections, which technicians can manage separately. IT support technicians perform disk management tasks like formatting drives, creating and modifying partitions, and managing disk space allocation. Effective disk management ensures efficient use of the storage space on a computer. Let's explore some of these disk management tasks. Manage partitions. Managing partitions involves creating, resizing, splitting, or merging partitions to organize data more effectively. For example, separating the operating system and applications from user data can simplify backups and improve performance. IT support technicians use command line tools or GUI applications for various partition management tasks. These tasks can include creating, deleting, resizing partitions, and changing partition types. The specific commands, tools, and software depend on the operating system. Format drives. Formatting a drive is a common task for IT support technicians, involving erasing all data on a drive and setting up a new file system. This process prepares the drive for use with an operating system. The steps IT support technicians perform to format a drive vary slightly depending on the operating system and whether the command line or graphical interface is used. If using the command line, the same commands will be used as if partitioning a drive. Important: creating and deleting partitions and formatting drives deletes the data on that part of the drive. Do not try any of these tasks on disks containing data the user needs. General considerations. Here are some general points that IT support technicians should consider when performing disk management tasks. Data backup. Before formatting, ensure all important data is backed up because formatting will erase all data on the drive. File system selection, choose a file system compatible with the intended use of the drive. For example, NTFS is commonly used for Windows, while ext4 is typical for Linux. Drive health check. Sometimes, it's a good practice to check the health of the drive before formatting, especially if it's being formatted because of errors or issues. Formatting drives is a fundamental skill for IT support technicians. It's important for setting up new drives or volumes, resolving certain types of errors, or repurposing old drives for new uses. IT support technicians should approach the task with caution because of the permanent nature of data deletion involved. Disk management tools. Technicians can use a variety of disk management tools including command line tools and graphical user interfaces, GUIs. Command line tools. Disk management command line tools are specific to the operating system. DiskPart is a Windows command line tool for partitioning and formatting partitions. fdisk is a Linux tool for partition management. Note, both DiskPart and fdisk are powerful tools, and it's crucial to use them with caution because incorrect commands can lead to data loss. An IT support technician should always ensure they back up data before performing partition management tasks. GUI tools. For complex partitioning tasks, especially on production systems, using more advanced tools with graphical interfaces might be more appropriate for better visualization and error prevention. Disk management is a Windows GUI tool for creating, deleting, and formatting partitions. Disk utility is a Mac OS tool for formatting partitions. GNOME Disks is a disk management utility for Linux. Download the Steps to Use Disk Management Tools document to keep as a reference for the steps to follow to use tools for disk management. Here is the extracted text from the image. Steps to use disk management tools. The steps to perform disk management tasks in command line tools vary depending on the operating system the client computer is running. Use DiskPart to create a partition on Windows. IT support technicians can use the DiskPart tool in Windows to manage partitions. Here's steps that an IT support technician might use to create and format a partition. Open the command prompt with administrative privileges. At the command prompt, type DiskPart and press Enter to start the DiskPart utility. Use the list disk command to display all the disk drives available on the computer. Choose a disk to partition by typing Select Disk Number, replacing number with the disk number. Create a new partition, using Create Partition Primary Size equals Size in MB. Replace size in MB with the required partition size. After creating a partition, format the new partition with a file system like NTFS using format fs equals NTFS quick. Use assign letter equals letter to assign a drive letter to the new partition. Replace size in MB with the required drive letter. Type exit to close the DiskPart utility. Use fdisk to create a partition on Linux. In Linux, one of the common command line tools for partition management is fdisk. Here's steps to use it. Open the terminal window. Type sudo fdisk-l to list the available disk drives and their partitions. Type sudo fdisk/dev/sdx, replacing /dev/sdx with the appropriate disk identifier to enter command mode for a specific disk. In command mode, you can create, edit, and delete partitions. Type N for a new partition and then respond to the prompts to input the type and size of the partition. After creating the partition, type W to write the changes to disk. Type sudo mkfs.ext4/dev/sdxn, replacing /dev/sdxn with the identifier for the partition, to format the new partition with an ext4 file system. Use disk management to format a partition or drive on Windows. Use the following steps to format drives using the disk management tool. In Control Panel, select System and Security, and then select Create and Format Hard Disk Partitions. In the center pane, select the drive or partition you want to format. Select the Action menu, select All Tasks, and then select Format. In the Format dialog, specify a volume label, choose a file system, and optionally specify a quick format. Select OK to format the partition or drive. Important, this action will erase all data on the drive. Use disk utility to format a partition on Linux. To format drives on Linux, use the disk utility tool. In the System menu, select Disk Utility. In the Storage Devices list, select the drive or partition you want to format. Right-click on the drive or partition, and then select Format Partition. In the Format Volume dialog, in the volume name field type a volume name, select a file system, and then select Next. In the Confirm Details dialog, select Format. Important, this action will erase all data on the drive. Let's practice in an activity so you can simulate using one of the GUI tools, the Windows Disk Management tool. Activity: use disk management to partition a disk and format a volume. Employability skills. Attention to detail, learning agility, collaboration and teaming. In this activity, you'll use a disk management tool to partition a disk and format a new volume. Scenario: you are working alongside Maggie, a senior IT support technician, to set up a computer for a new employee. The computer is currently running Windows and the new employee wants a dual boot setup of Windows and Linux. You need to create a new partition on the second drive to install Linux. You're new to using Windows Disk Management, so Maggie is going to walk you through how to use the new Simple Volume Wizard to partition the disk and format the new volume in preparation for the Linux installation. There are 19 steps to complete. Complete the following simulation. Step 1 19th. Maggie opens the Windows Control Panel window on the new computer and hands over the keyboard to you. To open the Disk Management tool, she asks you to select System and Security. Step 2 19th. Next, under Administrative Tools, select Create and Format Hard Disk Partitions. Step 3 19th. The upper pane of the window lists the existing partitions on the computer. Select the next arrow to continue. Step 4 19th. The lower pane of the window shows the two disks on the computer, Disk 0 and Disk 1. Notice the blue line above the partitions on Disk 0. This shows that the section of the disk contains a partition. Notice the black line above the whole of Disk 1. This shows that the space is currently unallocated. Select the next arrow to continue. Step 5 19th. Maggie explains that a partition using space from a single disk is known as a simple volume. She asks you to create a new partition on the unallocated space on Disk 1. Notice there is 931.48 GB of space available on Disk 1. The partition you create needs to be large enough to install Linux and the apps that the new employee will use, as well as their data. Maggie recommends it should be 100 GB. In the lower pane, select Disk 1, and then select Unallocated. Step 6 19th. Maggie explains that a partition using space from a single disk is known as a simple volume and asks you to use the new Simple Volume Wizard to create one. Select Action on the menu bar. Step 7 19th. In the Action menu, select All Tasks. Step 8 19th. Then, in the All Tasks menu, select New Simple Volume. Step 9 19th. The new Simple Volume Wizard dialog opens. Select Next. Step 10 19th. The Specify Volume Size page displays. Notice that the default simple volume size is the same as the maximum space available on the disk, 953,835 MB. Select the next arrow to continue. Step 11 19th. Maggie recommends using 100 GB for the new volume, which is equal to 102,400 MB. In the simple volume size in MB field, type 102,400. Then, press Enter. Step 12 19th. Select Next. Step 13 19th. Next, the Assign Drive Letter or Path page displays. You need to assign a drive letter for the new volume so that you can access it in Windows Explorer and other tools. Maggie tells you to use the default drive letter of D. Select Next. Step 14 19th. The Format Partition page displays. Select the File System drop-down list. Step 15/19. The wizard allows you to choose NTFS or XFAT for the file system. This setting controls how the operating system stores and tracks files on the disk. Maggie explains that XFAT is used on more operating systems than NTFS. With XFAT, the disk can be used on many operating systems without requiring reformatting. From the list, select XFAT. Step 16/19. Maggie explains you should use the default option for the allocation unit size field to enable the operating system to make the most efficient use of the space on the volume. She recommends that you change the volume label field to a more descriptive name so it's easier to identify in disk management tools. In the volume label field, type Linux drive, and then press Enter. Step 17/19. Select Next. Step 18/19. The completing the new Simple Volume Wizard page displays. Maggie asks you to review the settings you adjusted. Notice you selected to create a new simple volume of disk 1 with a size of 102,400 MB. You are using drive letter D, the XFAT file system with a default allocation unit size, and Linux drive for the volume label. All looks correct. Maggie instructs you to select Finish to create the partition. Step 19/19. The wizard creates the partition and displays it in the disk management tool. Notice that disk 1 now contains a new XFAT partition of 100 GB labeled as Linux drive. Select the next arrow to continue. Well done! You and Maggie successfully created and formatted a new partition on the new employee's computer so Maggie can install Linux alongside Windows in a dual boot setup. Disk cleanup. Like disk management, disk cleanup impacts a computer's storage system performance and efficiency. Disk cleanup is the process of removing unnecessary files from the hard drive. These might include temporary files, system cache, old system restore points, and files in the recycle bin. IT support technicians perform disk cleanups to help free up valuable disk space and improve system performance by reducing clutter and fragmentation. Disk cleanup includes tasks such as cleaning up temporary files, uninstalling unused applications, managing system restore points, defragmenting disks. Let's explore each of these in more detail. Cleaning up temporary files. Temporary file cleanup is a routine maintenance task that IT support technicians perform to enhance the performance and efficiency of computer systems. Everyday computing tasks like software installations, applications running, and operating system operations create temporary files. Over time, these files can accumulate and take up significant disk space, potentially leading to reduced system performance and slow operation. Regularly cleaning up these files helps free up disk space, improve system response times, and reduce the likelihood of errors and system conflicts. Each operating system provides different methods to clean up temporary files. Windows. Disk Cleanup Tool. Search for Disk Cleanup on the Start menu, select the drive you want to clean, and then choose the file types you want to delete. Windows Explorer. In the Windows Explorer address bar, type %temp% and then press Enter. Select all the files and folders, and then press Delete. Command line. Open a command prompt as an administrator. Type del/q/f%temp%\* to delete files in the temp folder. Mac OS. Finder tool. In the Finder window, select the Go menu, and then select Go to folder. Type /library/caches, and then press Enter. Delete the contents of the folders in this location. Terminal command. In the terminal window, type sudo rmrf/library/caches/*, and then press Enter to remove cache files. Use this command with caution because it will delete all the files in the caches folder, some of which might be currently in use. Linux. Terminal command. In the terminal window, type sudo rmrf/tmp/*, and then press Enter to clear the contents of the /tmp directory. In the terminal window, type cd/var/cache and then press enter to navigate to the cache directory. Type sudo rmrf* and then press enter to clear the cache files. Only technicians who understand the specific cache contents should use this command to avoid deleting required files. In all operating systems, it's important for IT support technicians to approach temporary file cleanup with caution, ensuring they do not inadvertently delete system-critical files. Regular cleanup not only helps maintain system efficiency, but also assists in troubleshooting because it removes potentially corrupt or outdated temporary files that can cause system issues. Uninstalling unused applications. Uninstalling unused applications is an essential maintenance task that IT support technicians perform to optimize the performance and security of computer systems. Over time, software and applications that users no longer need or use can accumulate on a system. These unused applications not only consume valuable disk space, but can also slow down the system. This can lead to potential software conflicts and also pose security risks if they are not updated. Regularly identifying and removing these applications helps maintain an efficient, secure, and clutter-free computing environment. Each operating system provides different methods to uninstall unused applications. Windows Control Panel. In Control Panel, select Programs and then select Programs and Features. Select an application to uninstall, and then select Uninstall. Follow the on-screen instructions for the application's uninstall process. Settings app. In the Settings app, select Apps and then select Apps and Features. Select an application to uninstall, and then select Uninstall. Follow the on-screen instructions for the application's uninstall process. Mac OS. Finder tool. In the Finder window, select Applications. Select an application to uninstall, and then on the File menu, select Move to Trash. To completely remove the application, empty the trash. Terminal command. In the Terminal window, type sudo rmrf/applications/applicationname.app replacing application-name.app with the actual application name, and then press enter to remove the application. Linux. Command line package managers. Different Linux distributions provide different command line package managers for installing and uninstalling applications. For Ubuntu, in the terminal window, type sudo apt-get remove application name replacing application name with the actual application name, and then press enter. For CentOS, in the terminal window, type sudo yum remove application name replacing application name with the actual application name, and then press enter. Graphical package managers. Different Linux distributions use different graphical package managers for installing and uninstalling applications. Examples include Ubuntu Software Center and Synaptic Package Manager. The steps are similar across them all. Open the Graphical Package Manager, select the application you want to remove, and then select Uninstall or Remove. For IT support technicians, it is important to regularly review and clean up installed applications, especially in an organizational environment where software needs can frequently change. Managing system restore points. System restore points are an important part of the maintenance and recovery strategies of IT support technicians. These are snapshots of a computer's state at a specific time, capturing system files, settings, and registry data. For technicians, managing these restore points is key to ensuring they have reliable rollback options in case of system errors or failures while also conserving valuable disk space. Efficient management involves creating, maintaining, and occasionally removing these points to balance between recovery readiness and optimal system performance. Each operating system provides different methods to manage restore points. Windows System Restore. Windows provides the System Restore feature for creating and deleting restore points. In the System Properties dialog, select the System Protection tab. From here, technicians can revert to a previous restore point, configure system restore settings, create restore points. By default, Windows is configured to create a restore point whenever someone makes major changes to the system, but it is good practice to create a restore point before making configuration or application changes. Backup management in Mac OS and Linux. Mac OS and Linux differ from Windows in how they handle system backups. Mac OS and Time Machine, IT support technicians can use Time Machine to set up and manage backups. It backs up apps as well as data and automatically manages space by deleting older backups when the disk is full. Linux and Time Shift, technicians can use tools like Time Shift to create a snapshot of a system in Linux. They can set schedules, choose what to include, and manage old snapshots using these applications. For IT support technicians, the careful management of system restore points and backups can help maintain system functionality and ensure quick recovery from software issues. Regular management of restore points, which might include creating new ones and purging outdated ones, helps balance storage space and recovery options efficiently. Defragmenting disks. Over time, as users create, modify, and delete files, those files can become fragmented. This means that parts of files are scattered across different areas of the disk. Fragmentation can lead to slower access times because the disk heads need to move more to read these scattered pieces. Disk defragmentation is a process that consolidates fragmented files and spaces on a computer's hard disk drive, HDD. IT support technicians perform disk defragmentation to optimize the efficiency of HDDs by reorganizing the files into contiguous blocks, thus enhancing the overall system performance, especially in terms of file access and read/write speeds. Each operating system provides different tools to defragment disks. Windows provides the defragment and optimize drives tool that technicians use to analyze the fragmentation of a disk. Defragment a disk. Schedule regular defragmentation. Mac OS. Modern Mac OS systems use the Apple File System, APFS, or earlier HFS and file systems. These are designed to avoid or minimize fragmentation. Therefore, disk defragmentation is not generally required or even available as a built-in utility in Mac OS. Linux. Like Mac OS, most Linux file systems like ext4 are designed to be resilient to fragmentation. For systems using Linux with an HDD and requiring defragmentation, technicians can use tools like E4defrag to check fragmentation levels and perform defragmentation. Disk defragmentation is relevant and beneficial for systems running on traditional HDDs, particularly in a Windows environment. For IT support technicians, regularly defragmenting HDDs in these systems is a key maintenance task to ensure optimal disk performance and system responsiveness. In contrast, with the advent of SSDs and modern file systems in Mac OS and Linux, the need for regular defragmentation has significantly diminished because these technologies inherently manage data storage more efficiently. System backups. Backing up a system is the process of creating copies of data, applications, and system settings to protect against data loss or corruption. Backups serve as a safeguard, allowing a technician to restore systems to a previous state in case of hardware failure, data breaches, accidental deletions, or other unforeseen events. For IT support technicians, performing regular system backups is essential for several reasons. Data protection. In the event of data loss because of system failures, malware attacks, or accidental deletions, backups provide a reliable means of recovery. System recovery. In case of critical system errors or failures, having a recent backup enables quick restoration of the system to its previous state, minimizing downtime. Compliance and security. Many industries have regulations requiring data to be backed up regularly. Moreover, backups are a key component of a robust cybersecurity strategy. Business continuity. For businesses, backups are vital for maintaining operational continuity. They ensure that technicians can quickly recover and restore essential data and systems. System backup methods. IT support technicians can use built-in backup utilities or third-party software to perform system backups. Built-in backup utilities. Windows provides the file history feature in Control Panel to create regular, scheduled backups of files. Technicians can configure where to store the backups, which folders to include, how often to save copies, and how long to keep the saved versions. Mac OS provides the Time Machine feature to automate hourly, daily, and weekly backups. It's an intuitive tool for backing up files to an external drive or network location. Third-party backup software. There are numerous third-party backup solutions offering advanced features like cloud backups, incremental backups, and more sophisticated scheduling options. These tools often provide more flexibility and functionality than built-in utilities. An organization might require the use of one of these tools. Storing system backups. IT support technicians should not store backups on the source computer to ensure that in the case of complete system loss, the backup files are still accessible. It is also advisable to store backups in a different physical location in case of fire or other destructive damage in that location. Physical media backups. For highly sensitive data or as a part of a comprehensive backup strategy, IT support technicians create backups on physical media like external hard drives or USB drives. Some users, such as graphic designers and photographers, prefer to have a physical media backup. And some organizations prefer to have complete control over their backup files. An icon of an external hard disk. Cloud-based backups. IT support technicians can also utilize cloud-based backup solutions, which offer scalability, remote accessibility, and often enhanced security features. Services like Google Drive, Microsoft OneDrive, iCloud, and various dedicated cloud backup services are commonly used. Cloud-based backups provide the advantage of being accessible from anywhere in the world. Summary and looking ahead. In this lesson, you learned about the regular system maintenance, disk management, disk cleanup, and system backup processes and tools that IT support technicians use to keep systems running well. These processes help maintain system efficiency, ensure data integrity, and provide a stable and fast computing environment. IT support technicians might perform these tasks as part of regular maintenance or be responsible for helping users perform these tasks on their own. The next lesson covers managing users, groups, permissions, and policies. You will learn how to manage users and groups effectively to simplify your day-to-day administration tasks. You'll also discover how to use configuration management software to easily manage large numbers of users and computers. About this lesson, managing users, groups, licenses, and policies. In this lesson, you'll learn about managing users to keep data secure in organizations. You'll discover the common permissions that IT support technicians grant to users to access information and services and identify the best practices they use to maintain security. You'll also learn about using groups to simplify user management and using configuration management software to efficiently manage their permissions. You'll examine best practices for license management and interpret results from a license audit. Finally, you'll explore how security policies can help manage the overall security of an enterprise. Effective user management. An IT support technician's job goes beyond just installing, updating, and maintaining operating systems. After setting up an operating system, they also take on the important task of user management, making sure everyone can use the system safely and smoothly. Employees working in an open office space. User management involves overseeing the creation, modification, and deletion of user accounts and associated permissions. It is essential for maintaining the security and operation of computer systems because it controls what each user can do within a system and helps prevent unauthorized access or misuse. IT support technicians are often responsible for several of the following user management tasks when setting up new computers and mobile devices. Create user accounts. IT support technicians set up new user accounts when employees join an organization or when existing employees require additional accounts. This process typically involves gathering user information, assigning a username, and setting up an initial password. Configure user profiles. After the IT support technician creates an account, they configure the user profile. This involves customizing the desktop environment, setting up email accounts, and configuring software settings based on the specific needs of the user. For example, a graphic designer might need different software compared to a salesperson. Assign permissions. An important part of user account management is determining and setting the appropriate level of access for each user. Technicians assign permissions that control what files, folders, and areas of the network a user can access, and to what degree. This is essential for maintaining data security and ensuring that users have the tools and data they need to perform their job functions. Manage passwords. Managing passwords is another key responsibility of IT support technicians. This includes enforcing password policies, such as minimum length, complexity requirements, and expiration periods, resetting passwords when users forget them, and educating users on best practices for creating secure passwords. Update user information. As employees move through different roles within an organization, their access needs might change. IT support technicians update user accounts to reflect these changes, modifying permissions and access as necessary. Delete or deactivate accounts. When an employee leaves the company or no longer needs access to certain systems, IT support technicians are responsible for promptly deactivating or deleting their accounts. This is a critical step to ensure that former employees cannot access company systems and data and ensure system security. Perform regular audits and compliance. IT support technicians conduct regular audits of user accounts to ensure that access levels are still appropriate and that there are no dormant accounts posing a security risk. Compliance with internal policies and external regulations is also a key consideration in managing user accounts. Access control. In the 1992 movie Sneakers, a team of thieves breaks into a bank. They encounter plenty of obstacles, such as security guards, alarm systems, and door locks. They successfully get past the security, break in, and steal a briefcase full of money. In the movie, the robbery helps the bank identify gaps that exist in their system. Similarly, in the computer industry, security professionals learn from threat actors and tighten their security measures accordingly. IT support technicians assist in securing systems by setting permissions as a part of access control. A large vault in a bank lobby. Image source, photo by Brock Wegney, opens in a new tab. R on Unsplash, opens in a new tab. Access control is a part of the overall user management process in which an organization determines who is allowed to access what resources, when, and under what conditions. Three key aspects of access control are identification, authentication, and authorization. Identification involves recognizing an individual or entity attempting to gain access to a system, facility, or resource. This process can be executed through various methods, such as requiring a username in digital systems or presenting ID cards in physical spaces. The effectiveness of access control hinges on the robustness of the identification process. It sets the stage for the subsequent authentication and authorization steps, ensuring that access privileges are granted appropriately and securely. Authentication, (authn), is a security measure that strengthens access points. Authentication allows only appropriate people or systems to enter a network and keeps others out. While identification aims to recognize a user, authentication aims to verify that the user is who they say they are. Identification asks, "Who are you?" and authentication asks, "Can you prove it?" For most systems, users authenticate their identity with a password. Some methods, including biometrics, can identify and authenticate users at the same time. Authorization, (authz), provides access to resources within a system. While authentication verifies that a person is who they say they are, authorization determines the level of access to resources a person has within the system after their identity has been authenticated. For example, a child wants to get a snack and goes into the kitchen. The child's parents want to allow the child in the kitchen but don't want them to be able to turn on the stove. The parents use the child lock on the stove to prevent the child from turning it on. The child is not authorized to turn on the stove and the child lock prevents them from doing so. These security steps work together like a series of checkpoints. Identification asks who a user is, authentication verifies if the user is actually that person, and authorization decides what the user can access. Each step is essential for controlling who gets into the system and what they can do there. IT support technicians often play a role in setting up, maintaining, and troubleshooting access control systems. However, a more frequent aspect of their duties is the management of users' permissions. Permissions determine what actions users can perform on files, folders, applications, networks, and system resources that they have access to. Let's discover some of the common permissions on files and folders. Review the following table. Read. The read permission provides the ability to view the contents of the file or folder. Write. The write permission provides the ability to write to a file and add files to a folder. Modify. The modify permission provides the ability to read and write to files and to delete files in a folder. Execute. The execute permission provides the ability to run an executable file or script. Best practices in user management for security. Effective user management and access controls ensure that the right individuals have access to specific areas of a system. Here are some best practices that IT support technicians perform to maintain security across their organizations. Review and update user permissions. IT support technicians should review and update user permissions regularly. By routinely assessing user roles and their corresponding permissions, organizations can ensure that each user's access is precisely tailored to their current job role. This minimizes the risk of unauthorized data access by preventing users from having more access than necessary. Enforce strong password policies. Strong passwords act as robust fences deterring potential intruders. They are the first line of defense against breaches. IT support technicians can significantly enhance the security of an organization by encouraging users to create complex passwords, possibly by using password managers, and mandating regular password changes. Limit administrative access. Administrative access gives a user access to all aspects of an operating system. Limiting who has administrative access can prevent many unnecessary security issues. By restricting the number of users with administrative privileges, organizations can reduce the risk of both accidental and intentional system alterations. This not only helps maintain the integrity of the system but also ensures that administrative power is only in the hands of those who truly need it and have the skills to use it responsibly. What do you think? Employability skills. Critical thinking. As a user, what best practices do you follow to use strong passwords on your computer or devices? Don't share your passwords. Share your approach or methods. Evaluate your thinking. Does your answer account for the following? Strong passwords use a random mix of uppercase letters, lowercase letters, numbers, special characters. They should not contain recognizable words or personal information, and every password you use should be unique. To learn more about strong passwords, check out Creating Strong Passwords, opens in a new tab, by the gcfglobal.org program. By adopting these best practices in user management, IT support technicians can help create a secure digital environment. Streamlining access, group management. Group management is a fundamental aspect of operating system administration. Groups streamline user management, allowing administrators to efficiently regulate access to files, folders, and resources. Group management is the process of organizing users into groups with shared permissions and access rights and managing those groups. Think of it like different club memberships. Everyone in each club gets the same benefits, but members in a different club might get a completely different set of benefits. Grouping users simplifies management, strengthens security, and makes the system more efficient. Understanding group management is important for maintaining system security and ensuring operational efficiency. Static and dynamic groups in system management. There are two types of groups that IT support technicians can create: static and dynamic. Static groups have fixed memberships. Dynamic groups automatically include users based on defined criteria. Static groups offer more precise control, but require more administration, such as manually adding or removing members of the group. In contrast, dynamic groups automatically update memberships, reducing an administrator's workload. However, they do need clear criteria for group inclusion. Knowing the distinctions between these groups can help IT support technicians efficiently manage users. The following table describes the differences between static and dynamic groups. Membership control. Static groups rely on manual addition and removal of members, whereas dynamic groups feature automatic membership based on set criteria. Administrative effort. Static groups require more administration due to manual membership handling, while dynamic groups reduce administrative workload because the group adjusts automatically. Precision of control. Static groups offer precise control over membership, whereas control in dynamic groups depends on the accuracy and relevance of the defined criteria controlling inclusion. Flexibility. Static groups are less flexible because updates require manual intervention, while dynamic groups are more flexible as they automatically adapt to changes in user status or attributes. Suitability. Static groups are ideal for groups with infrequent changes or where manual oversight is necessary, whereas dynamic groups are suitable for frequently changing memberships or where criteria can be clearly defined. Overall, a static group works well for groups of users that are unlikely to change, such as a particular project team. Dynamic groups work well for groups defined by characteristics, such as being members of a particular department or with a certain role. Role-based access control, RBAC, and group management. Role-based access control, RBAC, simplifies permissions by associating user roles with predefined sets of access rights. It streamlines group management by assigning permissions based on roles, enhancing system security and efficiency. RBAC ensures that users receive access tailored to their job responsibilities. It minimizes errors and enhances overall system management. RBAC promotes the principle of least privilege. Diagram showing three personas at the top of the image: an accountant, a manager, and a consultant. Below the three personas, there are four documents: financial reports, client information, account database, and consultant reports. Lines connect the accountant to financial reports and the account database. Lines connect the manager to all four documents. Lines connect the consultant to financial reports and consultant reports. Least privilege is a principle in which users are granted only the minimum level of access required to perform their job duties. This minimizes the risk of unauthorized access and potential security breaches. For example, imagine two different users, Tenessa, a sales manager, and Rob, an HR manager. RBAC would dictate the permissions of these users based on their role. The following table shows how the permissions between these two roles might differ and overlap. Here is a sentence breakdown comparing the permission types for Tenessa, sales manager, and Rob, HR manager, based on the image. Access to sales applications: Tenessa has access, while Rob does not. Access to HR management software: Tenessa does not have access, whereas Rob does. Manage user accounts in their department: both Tenessa and Rob have permission to manage user accounts in their respective departments. Read and write access to departmental files: Tenessa has access to sales-related files, while Rob has access to HR-related files. Access to company-wide financial reports: Tenessa has limited access restricted to sales performance, while Rob has full access. Modify their departmental settings: both Tenessa and Rob are permitted to modify their departmental settings. Access to employee personal data: Tenessa does not have access to employee personal data, whereas Rob does. View and edit customer information: Tenessa has permission to view and edit customer information, while Rob does not. Generate departmental reports: both Tenessa and Rob have permission to generate departmental reports. Notice that the sales manager role has access to sales applications and customer information, reflecting their focus on sales performance and customer relations. The HR manager role has access to the HR management software and employees' personal data, aligning with their role in managing employee-related matters. Both roles can manage user accounts and modify settings within their respective departments, but they do not have access to each other's specialized areas. There is some overlap in areas such as generating departmental reports, where both roles require access to perform their duties. This example demonstrates how technicians can finely tune RBAC to provide specific access rights based on distinct job functions while maintaining some commonalities where necessary for operational efficiency. You've learned about group management and ways that IT support technicians can streamline permissions by assigning users to either static or dynamic groups and using role-based access control to give certain permissions based on job functions. Activity: prepare permissions to manage users. Employability skills. Analytical thinking. In this activity, you'll be working alongside Felicia, an experienced IT support technician, to configure role-based access control, RBAC, for 3 newly onboarded employees. Your role is to use your knowledge of permissions to determine the most suitable permissions for each role based on the information provided. Well done! You successfully assigned the appropriate permissions to each role. This provides each of the new employees only the access they need to do their jobs while keep the system secure. Configuration management software. A computer policy icon. Group management can help efficiently manage user permissions, particularly for large organizations with hundreds or thousands of employees. But how do IT support technicians implement groups? That's where configuration management software comes in. Configuration management software enables IT support technicians to turn on or turn off specific settings on a device, enforce configurations across multiple computers within an organization. Configuration management software includes Group Policy on Windows, Profile Manager for Mac OS, and Puppet for Linux. Using configuration management software, technicians can define security settings, set up password policies, configure network settings, manage software installation, and much more. The software applies these policies across the organization, ensuring consistency and compliance with company guidelines and IT security standards. Many organizations have multiple levels of policies. For example, a company might have a policy that applies to every computer on its network for every employee. They also might have specific policies for employees in certain roles. Let's follow along as Blair, an IT support technician, uses configuration management software to ensure consistent configurations on new employee computers and for organization-wide changes. A woman holding a document while looking at a computer screen. Setting up new employee computers. Blair's day begins with configuring computers for new employees. Using the Group Policy tool, she remotely installs a standard set of applications on each computer. She ensures that all devices have automatic updates configured to keep the operating system and other software current and secure. These configurations are part of an organization-wide policy. Customizing access for different departments. Next, Blair focuses on tailoring access for various departments. She implements specific policies for each group. She gives software developers access to the code database and grants accountants access to financial records. She gives salespeople the ability to transfer files to thumb drives for clients, but disables USB ports for employees in HR. Blair carefully manages these types of permissions to ensure each team has what they need to do their jobs without compromising security. Managing networks and ensuring compliance. In the afternoon, Blair turns her attention to the wider network. She manages network-related settings through Group Policy, ensuring consistency across all devices connected to the domain. First, she sets up network security settings, including password requirements. Then, she configures remote access policies for VPN access. Finally, she deploys all network printer settings to the new computers. Configuring advanced settings and troubleshooting. Blair spends the last part of her day implementing more complex network configurations. She sets up IP management and DNS settings. She also focuses on network isolation policies for enhanced security in the research and development department. Network isolation refers to the practice of separating different parts of the network to enhance security. Blair also sets up network access protection, NAP, policies. NAP policies check if a computer has the latest antivirus updates, required software patches, or appropriate firewall settings before granting it network access. If a computer doesn't meet these requirements, the system denies access or places it in a restricted network until it becomes compliant. Using directory services for group management. Interwoven in her day's work, Blair uses directory services, such as Active Directory, to manage group settings. Directory services store information about various network resources such as users, groups, computers, printers, and services. It also allows administrators to manage these resources and their attributes. She uses these services to create and configure groups, efficiently managing memberships and access controls. This includes nesting groups for organizational hierarchy, which simplifies the administration of complex permission structures. Reflecting on the day's work. As the day winds down, Blair reviews the new computers. She checks for any issues and notes any changes made, preparing for audits and compliance checks. IT support technicians like Blair can use configuration management tools to manage, secure, and optimize network configurations and access. Effective license management. Along with user management, IT support technicians might be responsible for software licensing and license management. Software licensing refers to the legal agreement between the software creator and the user that governs how they can use the software. License management is the process of organizing and overseeing software licenses. Let's explore the various types of software licenses. Proprietary licenses permit the use of software under specific conditions determined by the creator or vendor. These terms often include restrictions on modification, sharing, and commercial use. Open source licenses allow users to modify and redistribute the software's code, but within the framework of certain terms that typically emphasizes sharing improvements and maintaining the open nature of the software. Freeware offers software for free use, but it often comes with certain limitations, such as restrictions on commercial use, distribution, or access to full features and functionalities. License management often includes overseeing the licenses for the operating systems themselves, as well as the software installed on them. IT technicians might need to keep track of the licensing terms for each operating system version, manage updates, and plan for upgrades, all while ensuring compliance with the operating system licensing agreements. Another part of an IT support technician's role is to install, update, and maintain software on operating systems across the organization. They must ensure that the number of software installations and the way the software is used align with the licensing agreements. A woman typing on a laptop while looking at a second monitor. Best practices in license management. There are many challenges involved with license management. Some licensing terms can be incredibly complex, making it difficult for organizations to properly keep track of and understand all of the nuanced details within. There are also multiple challenges involved when software licenses are used across different platforms. Ensuring compliance while dealing with diverse environments adds an additional layer of complexity. As businesses grow, their software needs and license requirements also evolve. Managing licenses at scale, especially in expanding organizations, requires an adaptable and efficient system. IT support technicians can help by implementing the following best practices to ensure compliance. Utilize a repository. It's often best for IT support technicians to create and maintain a centralized repository containing comprehensive information about all software licenses owned by the organization. This repository should include details such as license terms, renewal dates, usage limitations, and authorized users. Many organizations implement license management software for this purpose. This type of software helps technicians monitor installations and usage, ensuring that the organization does not exceed its licensed capacity and remains compliant with the terms of use. The software also alerts administrators about potential compliance issues, such as unauthorized software usage or exceeding the permitted number of installations. Audit periodically. IT support technicians should conduct periodic audits to verify compliance with license agreements. Monitoring systems or software can track software installations, usage, and compliance in real time. Regular checks help identify and rectify non-compliance issues promptly to avoid fines. Resolve issues promptly. IT support technicians should resolve licensing issues promptly to address compliance issues. When facing licensing issues, IT support technicians can take the following prompt and effective actions to resolve these issues while ensuring compliance and minimizing operational disruptions. Uninstall unauthorized software. If the software is installed without proper licensing, a quick solution is to uninstall it from the affected systems. This immediately addresses compliance issues. Purchase additional licenses. If the number of software installations exceeds the licensed quantity, purchasing additional licenses can bring the organization back into compliance. This can be difficult to accomplish quickly in some organizations. Reallocate existing licenses. Sometimes, licenses can be reallocated from systems where they are underutilized to those where they are needed, provided the licensing terms allow such flexibility. Contact the software vendor. For clarification or negotiation, reaching out to the software vendor can provide immediate guidance or temporary relief, such as grace periods to rectify the situation. Comply with the terms. For open source software where modifications haven't been shared as required, the immediate step is to comply with the terms by sharing the modified code according to the specific open source license. Review and educate. Review the specific terms of the license with the team to ensure everyone understands their obligations. Provide training or guidance on how to comply with these terms in the future. Next, let's review a case study about licensing to learn more. Case study: License Management for ADIN Inc. Employability skills. Attention to detail, analytical thinking. ADIN Incorporated is a mid-sized company with diverse software needs across various departments. The IT support team is conducting a comprehensive review of all company software licenses and ensuring compliance. The first step is to review the license inventory. The organization has 175 employees and uses 4 primary applications and an operating system. Review the following table to view the existing license inventory. Here is a full breakdown of the table converted into sentences for each software application. 1. Windows OS. License and type: Windows OS operates on a proprietary, per-user license. Quantity: there are 150 licenses available. Terms: it is installable on up to 2 devices per user. 2. Office Suite Pro. License and type: Office Suite Pro uses a proprietary, volume license. Quantity: there are 150 licenses available. Terms: it is for use on company devices only and is non-transferable. 3. Safeguard Antivirus. License and type: Safeguard Antivirus is a proprietary software with a site license. Quantity: it allows for unlimited installation within the company premises. Terms: the license includes regular updates and support. 4. Phoenix Database. License and type: Phoenix Database is an open-source software under the GPL v3 license type. Quantity: it offers an unlimited quantity of usage. Terms: users are free to modify and redistribute it, provided they share any improvements made. 5. ZenWriter. License and type: ZenWriter is provided as freeware, for both license and license type. Quantity: usage is unlimited. Terms: it is free for non-commercial use only. Using a license management tool, the IT support team conducted an audit of current software installations and compared them against the license inventory. Review the following table to view the results from the audit. Here is the breakdown of the table converted into clear sentences for each software application. 1. Windows OS. Quantity used: 175 units are used. Other notes: there are no other notes. 2. Office Suite Pro. Quantity used: 175 units are used. Other notes: some installations are on personal devices. 3. Safeguard antivirus. Quantity used, 175 units are used. Other notes, there are no other notes. 4. Phoenix database. Quantity used, 75 units are used. Other notes, modifications made to the software have not been shared. 5. ZenWriter. Quantity used, 35 units are used. Other notes, it is being used for commercial purposes in the marketing department. Your task is to conclude compliance issues found in the license management audit and the steps the IT support team can take to resolve the issues. Evaluate your thinking. Do your answers account for the following? Question 1. Non-compliance issues. The following applications are currently non-compliant with their licensing agreements. Windows OS, 175 employees are using Windows OS, but the company has only 150 licenses. Office Suite Pro, 175 employees are using Office Suite Pro, but the company has only 150 licenses. Some employees are using Office Suite Pro on personal devices, which violates the requirement for company device usage only. Phoenix database. Since company modifications to the software have not been shared, this breaches the open source terms. ZenWriter, the software is being used for commercial purposes in the marketing department, which violates the non-commercial usage terms. Question 2. Actions to take. The IT support team should take the following actions to ensure that ADIN Incorporated adheres to its software licensing agreements now and maintains ongoing compliance. Windows OS. The IT support team should either purchase 25 additional per-user licenses or reallocate existing licenses to ensure compliance with the 150 license limit. Office Suite Pro. The IT support team should either purchase 25 additional per-user licenses or reallocate existing licenses to ensure compliance with the 150 license limit. In addition, the team should uninstall the software from personal devices and reinforce the policy of using company-provided devices for company software. Phoenix database. The IT support team should share the modified code in compliance with the open source license and provide training about open source to employees for future compliance. ZenWriter. The IT support team should uninstall ZenWriter from devices in the marketing department and explore alternative commercial-friendly software solutions for them. Effective security policy management. Operating system security in an enterprise is like ensuring the safety of each door in a large building. Each door, operating system, has its own lock and key, security settings, and it's important that IT support teams manage these correctly to keep the entire building, enterprise, secure. IT support technicians use security policies to define safe ways of working within an organization. Policies outline what is acceptable and unacceptable behavior, as well as any actions that the organization might take if anyone breaches a policy. Importance of operating system security policies. In an enterprise, each computer's operating system is a gateway to the organization's data and resources. Just as one poorly secured door can be a risk to an entire building, one unsecured operating system can pose a threat to the entire enterprise. The following security policies are specifically tailored to operating systems to help manage these risks effectively. System updates and patch management. Regular updates are like changing the locks to newer, stronger ones as they become available. Policies should dictate how and when systems update to protect against known vulnerabilities. User account management. This is like keeping track of and regulating who has the keys to each door. Policies define how user accounts are created, managed, and removed, ensuring that only authorized personnel have access to the operating system. Software installation and access controls. Just as some doors might have restricted access, policies govern what software can be installed and who can access certain parts of the operating system, preventing the introduction of potentially harmful programs. Handling system-level security alerts. This is similar to having a response plan for when a door's alarm goes off. Policies should outline how to respond to security alerts, ensuring quick and effective action to potential threats. Developing effective operating system security policies. Creating these policies requires a deep understanding of the specific operating systems in use and the unique risks they face. When creating these policies, IT support technicians will have to do the following: assess risks, identifying what threats each type of operating system might be exposed to in the enterprise environment, set clear guidelines, establishing straightforward rules for software updates, user access, and system monitoring, involve stakeholders, collaborating with IT professionals, department heads, and end users to ensure the policies are practical and address everyone's needs, enforcing and updating the policies. Ensuring compliance with these policies is critical. It involves regular audits, monitoring systems for adherence, and updating the policies as new threats emerge or as the enterprise environment changes. This continuous process is like regularly checking each door in the building to ensure it is secure and functioning correctly. Operating system security policies in an enterprise environment are about keeping each door secure and functioning as it should. By focusing on critical areas such as system updates, user account management, and response to security alerts, enterprises can safeguard their data and resources effectively. This approach ensures a robust defense against potential security threats, keeping the enterprise safe and secure. Summary and looking ahead. In this lesson, you learned about user management tasks such as creating user accounts, configuring user profiles, and assigning permissions. You discovered how IT support technicians use identification, authentication, and authorization to control who is allowed to access what resources when, and you reviewed some best practices in user management for security. You learned how technicians use static or dynamic groups or RBAC to reduce the administrative overhead of securing data and assigning access, and then determine suitable RBAC permissions for employees with different roles. You reviewed how an IT support technician uses configuration management software to apply policies across an organization and how they use license management software to monitor license usage and remain compliant with license terms. Lastly, you investigated creating, using, and enforcing operating system security policies. The next lesson covers troubleshooting methods for operating systems. You'll discover symptoms of different types of operating system issues and how to use this information to diagnose and troubleshoot common operating system and application errors. About this lesson, troubleshooting operating systems. In this lesson, you'll learn about the tools and techniques IT support technicians can use to diagnose and troubleshoot operating system issues in Windows, Mac OS, and Linux. You'll uncover common causes of those issues, typical errors, and best practices that IT support technicians can use to troubleshoot them. Diagnosing operating system issues. Troubleshooting an operating system is an essential skill for IT support technicians. Operating systems manage everything from running programs to storing files, so when problems arise in the operating system, they can affect applications, network connections, and potentially the hardware itself. Man working on a computer in an office. IT support technicians can use a range of diagnostic tools to identify and fix issues within the operating system. Overall, these diagnostic tools have functionalities to provide a comprehensive health check of the computer, offer a detailed view of the computer's operations, including active programs, their memory usage, and the CPU workload, check for driver conflicts, detect resource management issues, detect errors in the system's configuration. By using these diagnostic tools, technicians can quickly pinpoint the root cause of the problem and take steps to fix it, so computers run smoothly again. Built-in diagnostic tools in operating systems. Built-in diagnostic tools are an essential feature of most common operating systems such as Windows, Mac OS, and Linux. These tools include Windows Task Manager, Mac OS Activity Monitor, Linux System Monitor. Tools such as these help an IT support technician to troubleshoot operating systems. They provide information about the state of the operating system, including a list of running processes and the CPU power and memory that each process is consuming. Here is the breakdown of the comparison table converted into clear sentences for each diagnostic feature. 1. Process list. Functionality, displays a list of all running processes. Diagnostic use helps identify which processes are active, consuming resources, or potentially causing system slowdowns. Tool support, supported by Task Manager, Windows, Activity Monitor, Mac OS, and System Monitor, Linux. 2. CPU usage. Functionality shows the percentage of CPU power each process uses. Diagnostic use aids in spotting processes that are using excessive CPU resources, which might indicate a problematic or rogue process. Tool support, supported by Task Manager, Windows, Activity Monitor, Mac OS, and System Monitor, Linux. 3. Memory usage. Functionality indicates the amount of random access memory, RAM, used by each process. Diagnostic use, useful for identifying memory-intensive processes, possibly leading to system lag if memory usage is too high. Tool support, supported by Task Manager, Windows, Activity Monitor, Mac OS, and System Monitor, Linux. 4. Disk usage. Functionality shows how much disk activity each process generates. Diagnostic use helps in detecting processes that are excessively writing to or reading from the disk, which can slow down the system. Tool support, supported by Task Manager, Windows, and Activity Monitor, Mac OS, support is limited in System Monitor, Linux. 5. Network activity. Functionality details network usage per process. Diagnostic use, useful for identifying processes that are using significant network resources, potentially affecting network speed. Tool support, supported by Task Manager, Windows, and Activity Monitor, Mac OS, support is limited in System Monitor, Linux. 6. Energy impact. Functionality provides information on the energy usage of each process, more prominent in Mac OS. Diagnostic use helps to identify applications that are draining battery life or consuming excessive power. Tool support, supported by Activity Monitor, Mac OS, support is limited in Task Manager, Windows, and not supported in System Monitor, Linux. 7. Performance graphs. Functionality offers real-time graphs for CPU, memory, disk, and network usage. Diagnostic use allows for a quick visual assessment of overall system resource usage, useful for detecting performance trends. Tool support, supported by Task Manager, Windows, Activity Monitor, Mac OS, and System Monitor, Linux. 8. Resource overview. Functionality provides a summary of overall system resource usage. Diagnostic use offers a quick glance at the health of the system, indicating if any resource is overly taxed. Tool support, supported by Task Manager, Windows, and System Monitor, Linux, support is limited in Activity Monitor, Mac OS. 9. Application management. Functionality allows users to end, restart, or manage running applications. Diagnostic use enables direct management of processes, useful for terminating unresponsive applications or processes. Tool support, supported by Task Manager, Windows, Activity Monitor, Mac OS, and System Monitor, Linux. Using a built-in diagnostics tool. Let's follow a scenario to learn about how IT support technicians use a diagnostic tool in their work to support users. Introduction. Meet Leo, an experienced IT support technician at a creative agency. The agency uses a variety of Apple computers running Mac OS for their design work. A user, Jordan, has reported that his Apple laptop has been running slowly, not just when using design software, but consistently across all tasks. Jordan mentions that even basic functions, such as opening folders or managing files, are sluggish, and sometimes the system becomes unresponsive. Leo meets up with Jordan and brings up the Mac OS built-in diagnostic tool, Activity Monitor, to diagnose the issue that Jordan is experiencing. 1. Access Activity Monitor. A screen capture of Spotlight search with AC typed in the search field and a list of possible apps to open displayed below it. Leo opens Jordan's laptop and presses Command and spacebar to open Spotlight search. He types Activity Monitor into the search field. He selects Activity Monitor from the search results to open it. The above screen capture shows the Spotlight search for Activity Monitor. 2. Review the computer processes. A screen capture of the CPU tab in Activity Monitor showing the processes running on the laptop. The kernel_task process is highlighted. The above screen capture displays the processes running on Jordan's laptop listed on the CPU tab in Activity Monitor. Leo first reviews active processes and their CPU usage on the CPU tab. He scrolls through the list to see if any applications or background processes are using an excessive percentage of CPU power in the %CPU column. Leo observes that the kernel_task process is consuming an unusually high percentage of CPU power, which is not typical during light system use. This indicates to Leo that the operating system could be struggling with a core function. 3. Monitor memory usage. A screen capture of the Memory tab in Activity Monitor showing the processes running on the laptop. The arrow by the Memory column heading and the Performance graph and Resource overview are highlighted. The above screen capture displays the processes running on Jordan's laptop on the Memory tab in Activity Monitor. Moving to the Memory tab, Leo determines if there are applications that are consuming large amounts of memory. He selects the arrow in the Memory column to sort the processes by how much memory they are using. In the lower pane, Leo notices the Performance graph and Resource overview. He checks available memory by examining the memory used. 4. Check energy usage. A screen capture of the Energy tab in Activity Monitor showing the apps running on the laptop. The above screen capture displays the apps running on Jordan's laptop on the Energy tab in Activity Monitor. Although Jordan hasn't mentioned any issues with battery life, Leo checks the Energy tab just to be sure there aren't any applications that are consuming excessive power. It doesn't appear there are, so he moves on to check disk usage. 5. Observe disk usage. A screen capture of the Disk tab in Activity Monitor showing the processes running on the laptop. The bytes written column heading is highlighted. The above screen capture displays the processes running on Jordan's laptop on the Disk tab in Activity Monitor. Although the macOS Activity Monitor has limited disk usage functionality, Leo checks for excessive read and write activity that might be slowing down the system. He examines the disk read/write speeds and checks to see if there is a lot of disk activity for any idle applications. He notices an unusually high number in the bytes written column, which might indicate an unusually high level of activity. Leo makes a note to check the system logs after finishing with the diagnostic tool. 6. Examine network activity. A screen capture of the Network tab in Activity Monitor showing the processes running on the laptop. The above screen capture displays the processes running on Jordan's laptop on the Network tab in Activity Monitor. Finally, Leo navigates to the Network tab, where he examines network usage per process to determine if any application is consuming a significant amount of bandwidth. The Network tab does not show any unusual activity, which further suggests that the issue is not with network-intensive applications. Summary. Using this macOS built-in diagnostics tool, Leo determines that none of the user-installed applications are causing Jordan's problem. Instead, the high CPU usage by system processes and high disk usage both point toward an operating system issue. This might be caused by a corrupted system file, an unsuccessful system update, or a deep-seated software conflict within macOS. Now that Leo has a theory that the operating system is causing Jordan's issues, he can continue troubleshooting the issue. Advanced diagnostic tools. Diagnosing operating system issues can be challenging because of the complex relationship between software components, the operating system, and hardware. Overlapping signs of different issues and inadequate error reporting further complicate the troubleshooting process. IT support technicians might need to use advanced diagnostics tools to fully diagnose and resolve operating system issues. These advanced tools provide the visibility and precision necessary for complex and persistent IT challenges. Select each section to learn more about advanced diagnostic tools for each operating system. Windows Tools. Event Viewer logs detailed information about significant events on a computer, such as program startup or shutdown and security incidents. IT support technicians can use it to find error messages that can lead to a diagnosis of a problem. Windows Performance Monitor, a powerful tool that provides system metrics and can track resources and performance in real time or through historical data. WinDBG, Windows Debugger, a more advanced tool for analyzing crash dumps, particularly useful when troubleshooting blue screen errors. Resource Monitor offers more detailed information than Task Manager about the use of hardware, such as CPU, memory, disk, and network, by processes and services. System Configuration Tool, Misconfig helps identify problems that services or startup programs might cause by selectively disabling or re-enabling them. Reliability Monitor provides a timeline of system events and reliability history, making it easier to spot trends and system stability issues. Memory Diagnostics Tool checks for memory problems, including testing of the RAM on a computer. Command Prompt or PowerShell enables running of advanced system commands and scripts for troubleshooting and system management. Mac OS Tools. Console. This log viewer is essential for diagnosing software-related issues by providing access to system logs, error messages, and application-specific logs. Terminal, a command line interface that allows advanced users to execute a wide range of diagnostic commands and scripts for in-depth troubleshooting. Disk Utility verifies and repairs disk permissions and checks for disk integrity, which can often solve and diagnose file system-related issues. System Information provides detailed information about the hardware and software on the Mac OS. This can be useful for diagnosing issues related to device compatibility and system changes. Linux Tools. HTOP, an interactive process viewer that offers a detailed view of running processes, their CPU and memory usage, and system performance metrics. JournalCTL, part of the Systemd suite, this command line tool allows users to query and display messages from the Systemd journal, a centralized log management solution. GNU Debugger, GDB. This debugger provides robust facilities for tracing and altering the execution of computer programs, which is vital for developers and IT professionals when diagnosing complex issues. IOStat, useful for monitoring system input/output device loading by observing the time the devices are active in relation to their average transfer rates. Strace, a diagnostic, debugging, and instructional utility for monitoring the system calls used by a program and the signals it receives. SAR, System Activity Reporter, helps collect, report, or save system activity information, ideal for historical performance analysis. After identifying an issue, IT support technicians use troubleshooting skills to resolve the issue. Common operating system problems range from startup and update issues to sluggish performance and software incompatibilities. Understanding these issues, their causes, and techniques for troubleshooting them in different operating systems is a key skill for an IT support technician. Let's explore some troubleshooting techniques for common issues across different operating systems. Troubleshooting boot and startup problems. Issues during startup can interrupt a computer's ability to start correctly. This might result in error messages, a failure to reach the login screen, or repeated restarting. Select each operating system to learn about how to troubleshoot boot and startup problems. Windows. Missing or corrupted system files can prevent Windows from starting. Windows has a database that includes boot time data called the Boot Configuration Data, BCD. This data provides information and parameters necessary to start the operating system. If the BCD is corrupted, users will encounter issues at startup. Corruptions like these can happen because of improper shutdowns, issues with the hard drive, or malware. How do IT support technicians troubleshoot this issue? Restart the computer and use the automatic repair function. When booting, choose the Repair Your Computer option, then start up Repair in the Advanced Options menu to access the automatic repair function. macOS. Missing or corrupted system files can also prevent macOS machines from starting. When these files become corrupted because of disk errors, malware, or unsuccessful updates, it can lead to system instability, errors, and boot problems. How do IT support technicians troubleshoot this issue? Start the computer in safe mode. To do this, turn on the Mac and continue holding the power button until the Startup Options window displays. Select the Startup disk, press and hold the Shift key, and then select Continue in safe mode. Linux. Linux systems might experience bootloader issues, which can prevent the system from starting correctly. These issues might also be related to corrupted boot files or incorrect settings. How do IT support technicians troubleshoot this issue? Use specific boot repair tools, such as Boot Repair, or access the system's recovery mode. For all operating systems, it's important to check for hardware failures and ensure drivers are up to date. These checks can prevent many boot-related issues. Troubleshooting update and upgrade issues in operating systems. It's important to apply regular updates to an operating system for security and optimal performance. However, sometimes, these updates can lead to challenges. Select each operating system to learn about troubleshooting update and upgrade issues. Windows. In Windows, updates can fail because of issues such as unstable internet connections or insufficient storage space. Incompatibilities between the update and existing software can also arise. How do IT support technicians troubleshoot this issue? Use the built-in Windows Update Troubleshooter to detect common issues with updates. Or, use the Windows System Restore feature to revert the system to a pre-update state if necessary. macOS. For macOS users, updates can encounter installation failures or conflicts with the current system setup, potentially leading to data loss. How do IT support technicians troubleshoot this issue? Update in safe mode to resolve the issue. Or, use a macOS safeguard with its Time Machine feature to restore the system to a point before the update. Linux. Linux systems, known for their varied distributions, can face update issues because of interrupted connections, insufficient storage, or dependency conflicts unique to Linux environments. How do IT support technicians troubleshoot this issue? Use the command line to reinstall the update. Unlike Windows and Mac OS, Linux does not have a system restore feature. But, it has time shift to create system snapshots for restoration. Regardless of the operating system, IT support technicians should ensure a stable internet connection and adequate storage space before updating an operating system. It is also important to perform regular backups to ensure the recovery of important data in the event of data loss during an update, minimizing potential disruptions. Troubleshooting performance issues. It's important to quickly diagnose and fix performance issues so that users can complete their tasks in a timely manner. Select each operating system to learn about troubleshooting performance issues. Windows. In Windows, performance issues can arise because of mismanagement of resources by the operating system bugs, and malware. Performance issues can also occur because of bloatware. Bloatware is software that comes pre-installed from the manufacturer that the user does not want or need. How do IT support technicians troubleshoot these issues? Use Performance Monitor to monitor resource usage. Update the OS. Remove or uninstall any unnecessary services. Use built-in Windows security software to scan for malware. Mac OS. Similarly, on Mac OS, performance issues can be caused by mismanagement of resources. In particular, performance issues can happen when system processes associated with indexing take up a significant amount of CPU usage. Two processes, MDS and MDWorker, can get caught in a loop and use excessive resources, causing slowness and unresponsiveness to the user. How do IT support technicians troubleshoot these issues? Turn indexing off and on using the commands in the terminal. sudo lonct unload w/system/library/launchdaemon/com apple.metadata.mds.plist. sudo lonct load w/system/library/launchdaemon/com apple.metadata.mds.plist. Linux. In Linux environments, performance issues might come from daemons consuming resources unnecessarily. In Linux, daemons are background services that perform various functions without direct user interaction. Mismanagement or misconfiguration of these daemons can lead to them consuming more system resources than necessary, leading to performance issues. Problems within the kernel, such as bugs or outdated modules, can also cause daemons to behave erratically. How do IT support technicians troubleshoot these issues? Use tools such as HTOP to identify which daemons are consuming excessive resources. Update the system to ensure all services and the kernel are up to date. For all operating systems, regular monitoring of system resource usage and regular updates and data backups are best practices to prevent performance issues. Troubleshooting driver and hardware compatibility issues. Driver and hardware compatibility issues across different operating systems can cause a range of problems, from reduced functionality to system crashes and device malfunctioning. Drivers facilitate communication between the operating system and hardware devices, such as graphics cards and network adapters. Select each operating system to learn about troubleshooting driver and hardware compatibility issues. Windows. In Windows, drivers and hardware can be incompatible with new operating system versions, or drivers might be unsigned. Old or damaged hardware can also cause compatibility issues. How do IT support technicians troubleshoot these issues? Check for the latest drivers provided by hardware manufacturers. Use compatibility mode for older hardware when installing drivers. Replace old hardware. In addition, IT support technicians can use Device Manager to review and update drivers. This supports rolling back drivers if a new version causes issues. Windows Update also routinely provides driver updates, making it easier to keep drivers current. Mac OS. In Mac OS, the controlled ecosystem and emphasis on security helps manage hardware and driver compatibility more strictly than in other operating systems. But, compatibility issues can arise when system updates deprecate support for certain hardware. The System Integrity Protection (SIP) feature blocks the installation of essential third-party drivers. The proprietary nature of Apple hardware interfaces can also contribute to compatibility issues with non-Apple peripherals, such as keyboards. How do IT support technicians troubleshoot these issues? Use the System Information tool in Mac OS to view detailed information about hardware and its corresponding drivers. This is useful for diagnosing problems related to hardware compatibility. They can address any issues found by ensuring all devices use the latest available drivers. Perform regular checks for software updates through the App Store to ensure that the system and Apple-approved drivers are up to date. For third-party devices, source drivers directly from the manufacturer's website. If issues persist, IT support technicians might need to cautiously disable SIP to install or update critical drivers. Linux. Linux handles drivers differently from Windows and Mac OS. It often integrates them directly into the kernel. So, driver and hardware compatibility issues can stem from kernel updates. They can also occur when using proprietary hardware or in the absence of official drivers for certain devices. Additionally, manual installation and configuration of drivers are more common in Linux compared to Windows or Mac OS, which can lead to potential misconfigurations. How do IT support technicians troubleshoot these issues? Use commands such as lspc or lsysib to list hardware and check for compatibility and available drivers. If technicians need proprietary drivers, they should install them directly from the manufacturer's website or through third-party repositories. Regular kernel updates are important, but technicians must ensure that these updates do not conflict with critical drivers. Use tools such as Dynamic Kernel Module Support, DKMS, to automatically rebuild kernel modules when updates occur, reducing the likelihood of driver-related issues post-update. For all operating systems, it's important to regularly check for driver updates to ensure hardware compatibility and optimal performance, especially after system upgrades. If issues arise after an update, using the operating system's tools to roll back drivers, check for compatibility, or even reinstall drivers can resolve many common problems. Using OS tools to troubleshoot desktop software installation issues. Application installation programs can often resolve issues during software installation. However, in some scenarios, IT support technicians might use operating system tools to troubleshoot a problem related to a failed or faulty software installation. This is common in corporate environments when using complex or automated software installations. Tools on Windows. Microsoft Windows is currently the most widely used desktop operating system by both corporations and individual users. Windows provides tools as a part of the operating system that helps technicians manage and troubleshoot software installation. The following are 2 Windows tools that technicians use to manage software installations. Windows Management Instrumentation Command Line, WMIC. This is a command line interface to WMI. WMI is Windows Management Instrumentation, which enables scripts and software to monitor and manage Windows operating systems and installations. MICI-exec, this is the executable file for the Windows installer. It's used for installing, maintaining, and removing software on modern Windows systems. The command provides a way to install, modify, and perform operations on Windows installer from the command line. Both tools can be very useful for troubleshooting software installation issues on Windows. They provide detailed information and control over the installation process and system configurations, which can help in identifying and resolving problems. Using WMIC. The basic syntax of a WMIC command is OMIC alias where clause action clause. Alias, this refers to the WMI class you're querying. For example, a product, process, or service. Where clause, this is an optional clause that technicians can use to filter the results of the command based on certain criteria. Action clause, this specifies what action to perform. For example, use get to retrieve information or list to list items. Select to view a screen capture of WMIC. The following screen capture shows how to use WMIC in Windows PowerShell to find out information about the versions of Microsoft Office installed on a computer. The alias specifies querying the products on the computer, the where clause specifies only searching for products containing the word Office, and the action clause specifies retrieving the version information about that product. The results of the command show there are 2 products that include the word Office installed on the computer, both with the same version number. IT support technicians can use WMIC commands to retrieve information about a computer, run commands, and configure and delete software on a computer. Using MICI-exec. MICI-exec is the main executable for the Windows installer application. IT support technicians can use it from the command line to install, update, and repair installations that use the MSI technology. The basic syntax for using the MSI installer is MICI-exec /option optional parameter. Option, this specifies the action to take using a letter or word. For example, use /I to install software, use /X to uninstall software, use /F to repair software, and use /A to perform an administrative install. Required parameter, this is any information that the action requires, for example, the path to the MSI file or a product code. Optional parameter, this is any additional information to modify the command's behavior. For example, use /quiet to run the installation without any user interaction or use /log to create a log file with information about the command. Select to view a screen capture of MICI-exec. The following screen capture shows how to use MICI-exec to repair an installation of a tool called PowerToys. Notice it is running the following command, MICI-exec /f PowerToys setup.msi. Using WMIC to query, configure, and delete software installations and using MICI-exec to customize installations gives IT support technicians helpful tools for troubleshooting and resolving Windows software installation issues. Tools on Linux and Mac OS. Both Linux and Mac OS are less often used in corporate environments, but both offer tools to help manage software installations. Because both are based on Unix, their tools tend to be similar in style and functionality. Linux distributions typically use package managers for software installation and management. Common package managers include apt for Debian-based distributions and yum or DNF for Red Hat-based distributions. While Mac OS has its built-in software management tool called the App Store, some users prefer Homebrew for managing the installation of software, especially developer tools and command line utilities. It's a package manager like those in Linux, but it's specifically designed for Mac OS. Package managers are command line tools, although developers have created friendly user interfaces for some of them. Installing software and managing software installations using package managers typically requires simple commands. The following series of screen captures demonstrate commands for Homebrew for Mac OS to install and manage a software package called UGit. UGit is a free program that IT support technicians use to get content from web servers. Responding to critical and non-critical operating system errors. Operating system errors come in various forms and can cause programs to crash, freeze the screen, or even make the entire computer stop working properly. These errors can be caused by a multitude of factors, such as software glitches, hardware malfunctions, or simply user mistakes. Understanding these errors helps technicians troubleshoot problems and find solutions to get computers back on track, much like finding an alternative route when faced with a roadblock. By differentiating between the various types of errors, they can better identify and address the issues that arise. Let's learn about critical and non-critical operating system errors, and best practices for handling them. Critical operating system errors. Critical operating system errors are significant disruptions in a computer's functionality. They can lead to system crashes, resulting in the computer stopping abruptly and potentially losing unsaved data. Critical operating system errors appear differently across operating systems, but all have the same impact on users and data. Windows blue screen. The Windows blue screen, sometimes called the blue screen of death, BSOD, appears when Windows encounters a critical error. It displays an error message and code on a blue screen. Mac OS kernel panic. Kernel panics in Mac OS appear as a gray screen displaying a message telling the user to restart the computer. The message displays in multiple languages on the same screen. Linux kernel panic. Kernel panics in Linux display an error message and technical error information on a black screen. Critical operating system errors often result from hardware issues, incompatible drivers, and software conflicts. They signify that the system cannot operate safely and must restart. If critical operating system errors frequently occur, an IT support technician needs to investigate the underlying cause and resolve the issue. Critical errors that impact all operating systems. In addition to critical operating system errors such as blue screens and kernel panics, all operating systems can encounter other critical errors that impact users. System freeze. In a system freeze, the operating system becomes unresponsive, and input devices do not respond to user actions. They typically require a restart to resolve them. Software conflicts, shortage of memory, or hardware failures can cause system freezes. IT support technicians should investigate system logs and run diagnostic checks to identify and resolve the issue. Boot failures. The computer fails to start properly, often getting stuck on a loading screen or entering a continual restart loop. Corrupted system files, failed updates, and hardware malfunctions often cause boot failures. To resolve the issue, technicians need to boot into safe mode, repair the boot file, or restore the system from a backup image. Application crashes. These happen when an application closes unexpectedly, often after displaying an error message. They are usually related to software bugs, compatibility issues, or a shortage of system resources. If an application frequently crashes, an IT support technician should check for updates for the application and apply any available ones. They should also investigate the compatibility of the application with the operating system and try repairing or reinstalling the application. Understanding these critical issues across operating systems is important for maintaining system health and stability. It empowers users to identify, troubleshoot, and resolve problems more effectively, ensuring smoother operation and longevity of their systems. Non-critical operating system issues. Operating system errors can vary in their impact on a computer. Non-critical errors and issues are noticeable, but they don't severely hinder a computer's main functions. Imagine these errors as minor annoyances in an otherwise smoothly running machine. They often show up as small bugs or quirks in how things display or behave on the screen. For example, you might see an icon vanish for a moment, or a program might briefly stop responding. These are less severe issues that don't typically cause data loss or major disruptions. However, they can still affect a user's experience, and IT support technicians should address them to retain optimal system performance. Following is a list of some common non-critical operating system issues that users can encounter. You can reveal the symptoms and troubleshooting steps to take. Slow system performance. Symptoms: the computer operates slower than usual, applications take longer to open, or files take longer to load. Troubleshooting steps: an IT support technician can clear temporary files, optimize startup applications, or suggest upgrading hardware, such as RAM, for better performance. Unresponsive application. Symptoms: an application freezes and doesn't respond to commands. Troubleshooting steps: the common approach is to force quit the application and restart it. If the issue persists, reinstalling the app or updating it to the latest version can help. Impaired network connectivity. Symptoms: difficulty in connecting to the internet or network resources. Troubleshooting steps: resetting the network settings, checking router configurations, or updating network drivers are typical solutions. Printer and peripheral problems. Symptoms: the computer does not recognize a printer or other connected device, or the device does not function as expected. Troubleshooting steps: an IT support technician should check cables, ensure the correct installation of drivers, or troubleshoot connectivity problems. Minor GUI glitches. Symptoms: brief flickering, occasional distortion in images or icons, or temporary display issues. Troubleshooting steps: update graphic drivers, adjust display settings, or, in some cases, check for hardware issues. Understanding both critical and non-critical errors is key for comprehensive system health management. An IT support technician should be well versed in troubleshooting both critical and non-critical operating system errors to provide a holistic approach to system maintenance. Best practices for diagnosing and responding to operating system errors. When addressing operating system errors, employing the right strategy is crucial. The following list outlines the best practices IT support technicians can follow to effectively diagnose and respond to these errors. A woman working on a laptop. Prompt action and documentation: when an error occurs, immediately note any error messages or codes. This information is often essential to identify the issue. Initial troubleshooting steps: begin with straightforward solutions, such as restarting the system or reopening a problematic application, to resolve minor issues. Utilize diagnostic tools. Use tools such as Windows Event Viewer or Mac OS Console to access logs and details about system events. These are useful for diagnosing both critical and non-critical errors. Regular system maintenance. Regularly update operating systems and antivirus software to prevent many common errors. Educate users. Encourage routine system checks and updates to significantly reduce the occurrence of errors. Develop a troubleshooting methodology. Establish a systematic approach to troubleshooting, including steps such as reproducing the error and consulting technical forums. Backup and data protection. Ensure that recent backups of critical data are always available as a safeguard against potential data loss because of errors. Stay informed. Keep up to date with common issues and solutions related to your operating system by following online forums, official support sites, and tech news. Practice good cyber hygiene, promote safe internet practices and the use of reputable software to minimize the risk of malware-related operating system errors. Recognize your limits, understand when an error is outside your expertise and escalate complex issues to more experienced colleagues or specialists. Following these best practices can lead to effective management and resolution of operating system errors, contributing to the smooth operation of computer systems. A proactive and knowledgeable approach is often key to successful troubleshooting. Resolving application crashes and freezes. A woman speaking on a mobile phone and holding a laptop while standing in her living room. Application crashes can be frustrating. Especially when you're working on an important document, and the app stops responding or closes altogether without letting you save your work. But sometimes, application freezing is even more frustrating. Often, it feels like the application is stuck, you can see it on your screen, but no matter what you do, it's unresponsive. While both crashes and freezes can be bothersome, they can also hint at underlying issues within your system. Let's explore the causes and how to diagnose and resolve application crashes and freezes from an IT support perspective. Common causes of application crashes and freezes. Application crashes and freezes are common challenges faced by users across various operating systems. Often, these disruptions can be traced back to underlying issues within the operating system itself. While some users might perceive these crashes as mere inconveniences, they usually signify deeper problems that need addressing. A laptop with a snowflake displayed on the screen. Bugs in the operating system, ranging from minor glitches to more significant flaws, can interfere with the smooth functioning of applications. These bugs can manifest in various ways, such as resource allocation problems, driver conflicts, or corrupted system files. All these issues can impact the stability and performance of applications. The following are common causes of application crashes and freezes that IT support technicians must know about so they can identify them when operating systems have issues. Resource allocation problems. When a marathon runner needs more energy than a quick snack provides, they might stop or slow down. Similarly, when an application demands more resources than what the system can provide, it might crash or freeze. For example, a graphic design application might freeze when handling large files if the system lacks sufficient memory or processing power. Hardware driver issues. Drivers provide the communication between hardware and software. They act as translators between the two. Just as incompatible or outdated translations can lead to miscommunication, incompatible or outdated drivers can cause application failures. For example, an outdated graphics driver might cause a video game to crash or display graphical glitches. System file corruption. System files help instruct an operating system or application on how to function. In the same way that a flawed instruction manual can mislead an engineer, corrupt or misplaced system files can result in erratic application behavior and crashes. For example, corrupted system files in Mac OS can lead to frequent crashes of productivity software. In all these cases, an IT support technician needs to be able to correctly identify what underlying issue is causing the unexpected behavior. Diagnosing application crashes and freezes. Diagnosing application crashes and freezes involves a methodical approach to uncover the underlying issues within the operating system. Let's follow a scenario to learn about the process a technician follows to diagnose an application crash. Introduction. A woman sitting at a desk with a laptop and additional monitor. Meet Rose. She's an IT support technician working for a large corporation. She knows the key to diagnosing application crashes and freezes for the employees she supports lies in careful observation and analysis. Identifying patterns of when and how these crashes occur provide her with the first clues. 1. Review system logs. Rose starts by reviewing system logs. She knows that these offer a detailed record of system activities and errors, as well as providing insights into application malfunctions. She thinks of them as detectives' notes, offering clues to the source of the problem. Rose reviews the times of recurring errors or activities that occur prior to an error to gather clues to its cause. 2. Monitor resource usage. Next, Rose monitors resource usage to discover if specific applications are overtaxing the system's capabilities. She observes how much memory and CPU power an application is using to check whether it is overburdening the system. She thinks of it like financial budgeting, ensuring essential needs are met without overspending. For example, a high CPU usage figure for a browser application can indicate a large number of tabs open in that browser. The browser's use of CPU power will reduce the power available to other applications, potentially causing problems for them. 3. Utilize diagnostic tools. Rose then uses the operating system's built-in diagnostic tools to further aid her to pinpoint problem areas. She knows that built-in diagnostic tools offer comprehensive insights into the system's health and potential causes of application issues. She uses these tools as health check UPS and to reveal underlying issues. For example, the Mac OS Activity Monitor might show an application consistently using excessive memory, hinting at a need for optimization. Summary. This approach not only helps Rose to resolve the immediate issues, but also contributes to her understanding of the system's overall health and performance. By adopting these practices, Rose can effectively navigate and resolve the complexities of application crashes and freezes, enhancing her users' overall computing experience. Resolving operating system issues. Resolving operating system issues is a critical skill for ensuring the smooth functioning of applications and overall system stability. When applications crash or freeze, the root cause often lies in the operating system. These problems can range from outdated drivers and software bugs to corrupted system files and resource allocation errors. A laptop with a sad face displayed on the screen. What can IT support technicians do? Effectively addressing these issues involves a combination of updating system software, running diagnostic tests, and optimizing the system's performance. Let's explore techniques that technicians can perform to resolve OS issues. Update operating system and drivers. Just as routine vehicle maintenance keeps your car performing well, regularly updating operating systems and drivers can keep a computer performing well. Updates can help resolve known issues and enhance compatibility. For example, Windows updates often include fixes for known bugs that cause specific applications to crash. By applying the update, an IT support technician can avoid having to identify and resolve the application issue before it causes problems for a user. Perform disk checks and system file repairs. IT support technicians should perform regular disk scans to locate errors and corrupted files. This type of maintenance can prevent application issues from impacting users. Manage system resources. Like switching off lights in occupied rooms, closing unnecessary applications can avoid wasting resources. In the case of computer applications, it prevents them from overloading the system and saves resources for the primary applications. IT support technicians can use task managers to identify resource-intensive background processes that impact the performance of a user's main applications. If the background processes are never used, they can disable them to free those resources permanently. Free up storage space. Often, when you buy new clothes, you need to clear old items from your closet to make room for the new ones. Similarly, regularly cleaning computer storage by removing unused files and applications can create space for other processes and enhance system performance. By applying these techniques, IT support technicians can not only resolve existing issues but also enhance the overall performance and reliability of their operating systems, leading to a more efficient and enjoyable computing experience. Applying preventive measures and best practices. Prevention is often more effective than a cure. This principle is especially true when it comes to managing and preventing application crashes and freezes in operating systems. Both IT support technicians and users can adopt a series of preventative measures and best practices to reduce the occurrence of disruptions and ensure a more reliable experience with their devices. Each of the following best practices is aimed not only at preventing OS issues, but also at enhancing the overall health and performance of the system. Select each tab to learn about preventive measures technicians and users can perform. Update system regularly. Staying up to date with system and application updates can fix bugs before they cause applications to crash. For example, installing the latest iOS updates to an iPhone helps avoid common application crashes. Maintain adequate free space. Ensuring there's enough free space on a device can improve its performance and reduce application crashes. For example, regularly clearing cache and temporary files on an Android device helps to maintain optimal device performance. Install software safely. Installing applications from reputable sources minimizes the risk of introducing unstable or harmful software. For example, downloading applications only from the Google Play Store or Apple App Store helps to avoid malware-infected software. By understanding these detailed aspects and applying best practices, IT support technicians and users can significantly reduce the occurrence of application crashes and freezes, ensuring a more stable and efficient digital experience. Summary and looking ahead. In this lesson, you learned about troubleshooting operating systems. You learned about diagnostic tools, troubleshooting techniques, common errors, and best practices to perform across the different operating systems. IT support technicians need the skills and tools to diagnose and fix issues as they arise to help keep the computers in their organization functioning for employees. You've completed the final lesson of this module. Next, you'll review the module's key points and explore additional resources related to operating systems. Points to remember. Key concepts. 1. Operating systems are the fundamental software that manage the hardware and software resources of a computer or mobile device. They manage tasks, allocate resources, and provide a user interface to interact with the device. 2. Common operating systems include Windows, Mac OS, Linux, iOS, and Android. They each offer unique features, catering to a variety of user requirements. 3. The process of installing and configuring operating systems involves 7 steps. Choose an operating system. Backup data. Create installation media. Begin installation. Install the OS. Customize settings. Complete installation. 4. After installation, an IT support technician needs to install drivers, install essential software, restore data, and create recovery media. 5. Configuring a desktop operating system involves configuring system settings, setting up network connections and user accounts, and customizing the desktop environment. 6. Common accessibility features that technicians support and might need to adjust features based on users' needs include screen readers, text-to-speech, magnification and so on, high contrast themes, speech recognition, closed captioning, keyboard customization, and mouse and touchpad adjustments. 7. Regular system maintenance for operating systems includes updating operating systems, software, antivirus software, and hardware drivers. It also includes security updates, disk cleanup and management, performance optimization, and system backups. 8. Disk management includes managing partitions and formatting drives. 9. Disk cleanup includes the following tasks: cleaning up temporary files, uninstalling unused applications, managing system restore points, defragmenting hard disk drives. 10. System backups create copies of data, applications, and system settings to protect against data loss or corruption. 11. User management oversees creating, modifying, and deleting user accounts and their associated permissions. 12. IT support technicians can be responsible for several tasks related to user management: creating user accounts, configuring user profiles, assigning permissions, managing passwords, updating user information, deleting or deactivating accounts, performing regular audits and compliance. 13. Access control is the process by which an organization determines who is allowed to access what resources, when, and under what conditions. 3 key aspects of access control include identification, authentication, and authorization. 14. Permissions determine what actions users can take on files and resources. These permissions include read, write, modify, delete, and execute. 15. Group management is the process of organizing users into groups with shared permissions and access rights and managing those groups. Groups can be either static or dynamic. 16. Role-based access control, RBAC, simplifies access control by assigning permissions based on user roles and responsibilities. 17. Software licensing is the legal agreement between software creator and user, and license management is the process of organizing and overseeing software licenses. 18. Operating system issues can affect applications, network connections, and hardware. 19. Operating systems include these popular diagnostic tools: Windows Task Manager, Mac OS Activity Monitor, Linux System Monitor. 20. Common operating system issues include boot and startup problems, update and upgrade issues, performance issues, compatibility issues. 21. IT support technicians can use operating system tools to troubleshoot software installation issues, including WMIC and MISI-exec on Windows and package managers on Linux and Mac OS. 22. Critical operating system errors, such as blue screens in Windows and kernel panics in Linux and Mac OS, often result from hardware issues, incompatible drivers, and software conflicts. They result in the computer stopping abruptly and potentially losing unsaved data. 23. Other critical errors that can impact operating systems include system freezes, boot failures, application crashes. 24. Non-critical operating system errors, such as slow performance, unresponsive applications, impaired network connectivity, peripheral problems, and minor GUI glitches, can also impact users, but to a lesser extent. 25. Application crashes and freezes can result from resource allocation problems, hardware driver issues, system file corruption. 26. IT support technicians can troubleshoot application crashes and freezes using system logs, resource usage information, and diagnostic tools. 27. Best practices to avoid application crashes and freezes include applying regular system updates, maintaining adequate free disk space, installing software safely. Big ideas. In addition, you explored or practiced these skills. Employability skills. Resourcefulness. Reflect on accessibility features that help users with and without visual impairments. Attention to detail. Use the Windows Disk Management tool to partition a disk and format a new volume for user to have a dual boot setup of Windows and Linux. Interpret results from a license management audit. Determine the OS issue based on symptoms reported by a user in an IT support ticket. Apply troubleshooting techniques for different OS issues. Learning agility. Demonstrate adaptability to learn about Windows Disk Management to support a user. Collaboration and teaming. Work alongside a senior colleague to perform disk management tasks. Analytical thinking. Apply the steps to install and configure an operating system and printer for a new user. Determine the most suitable permissions for a given role for role-based access control, RBAC. Conclude compliance issues found in the license management audit and the steps to resolve the issues. Critical thinking. Consider best practices for strong passwords. Determine the OS issue based on symptoms reported by a user in an IT support ticket. Apply troubleshooting techniques for different OS issues. Career management skills. Identify IT support technician job roles. Summarize the skills needed to be an IT support technician. Learning objectives. Now that you've completed this module, you should be able to compare the features of popular desktop and mobile operating systems. Apply the steps to install and set up an operating system. Determine the processes to perform various regular system updates. Use a disk management tool to create and format a new partition in storage to install a second operating system. Select a system backup and storage method. Distinguish between user management tasks to manage operating system security through users, groups, permissions, and policies. Prepare permissions to manage users. Interpret results from a license audit. Select diagnostic tools and troubleshooting techniques across operating systems for issues and errors. Apply appropriate troubleshooting techniques to common operating system issues. Explore more resources. To explore concepts covered in this module in more depth, check out these resources. What is an operating system? Opens in a new tab. In this article, CompTIA explains how operating systems and the kernel work. What is backup and restore? Opens in a new tab. This IBM article discusses backup devices and solutions. Troubleshoot operating system service issues. Opens in a new tab. This Microsoft Learning module discusses how to troubleshoot issues in Microsoft Windows. 10 basic troubleshooting tips to fix common Mac OS problems. Opens in a new tab. This article by Christian Zabreg for Make Use of MUO shares troubleshooting tips for common Mac OS problems. Common Linux troubleshooting techniques for diagnostics. Opens in a new tab. This blog by Graham Messina for CBeat Nuggets presents common troubleshooting techniques and diagnostic applications for Linux.